Kalau mau ngasih file
Ini di sini, Pak.
di sini.
Ya.
Nanti mic dari mana ya?
Apsar.
Mic yang dari Zoom masuk oh itu ya? Iya. Oh komputer itu ya?
Pak, dorong.
Videonya udah di-download semua. Videonya sudah. Oh, sudah. Iya. Indonesia Raya juga. Iya. Oh, aman. Yang ini yang besar yang tolongan ya, yang sama sponsor ya. Iya. Aduh, wah, Bu Rika tadi yang Apsar yang terbaru di mana katanya? Jangan yang sub. Kalau nggak saya kopiin dari komputer saya. Tadi udah dikopikan ke flash disk. Hah? Yang sub, yang long aja. Yang long tuh yang mana? Yang plus sponsor. Dicoba aja, Pak. Sebentar, belum ke copy mungkin. Atau tadi yang coba dimunculkan. Belum coba dibukain.
Ini Pak.
Apsar. Bu Rika disimpan di mana videonya tadi itu?
Di video.
Video.
Dan di situ.
Yang itu.
Namanya yang sama.
Jangan-jangan yang only, yang plus sponsor. Oh, berarti yang plus sponsor.
Belum di-download.
Ditutup aja. Buka ke WA aja tuh. Ke ini. Bu Rika dikopikan di situ udah di-download atau di mana? Oh ini. Enggak. Ya, harusnya di salah satu. Mbak Rika mungkin. Ini nggak di sini, ini di belakang. Di sini aja, di sini sering bilang ya ada tapi ada yang nanti kalau mau perlu apa dia ambil di sini. Ini aja, taruh di sini. Kakaknya udah tinggal punya. Iya. Ada di sini. Di sini. Ini di sini. Nggak ada, harusnya ada. Mana tuh? Gimana kita tuh? Udah connect. Dokumen. Ini di mana dapat itu? Di depan. Kita nggak ada di sebagai display presentation. Harusnya kan ada display setting. Cara tahu kan? Kalau cara saya nggak tahu. Ini sebagai.
Harusnya di sini di display deh.
Kan jadi atau buka dulu ya.
Iya coba.
Belumnya di organ Indonesia.
Kok nggak bisa diceknya tadi?
Plastisnya mana Pak?
Plastisnya itu.
Di sini
Bisa. Oh iya. Mas, kopikan dulu ada di kemarin. Kopikan dulu. Ini yang industrial session. Pak Ade, punten. Punten.
Ada Apsarnya, Apsar.
Final industrial session. Ini Ade Komara. Komara. Gede masalahnya ya. Komputer yang sama. Malam nggak bisa gabung pada sore. Oh, tidak bela.
Sudah ada signya, Pak. Ada signya.
Kalau tadi sih pertama bisa tadi pagi sih bisa tadi di restart aja lah ya. Restart aja nggak apa ya?
Dibilang sudah ada signya.
Terus kemudian tadi sebelumnya sih mau ya.
Restart dulu. Restart dulu.
Restart aja
Iya,
dulu.
masih ada waktu.
Jadi
Then you have to try to utilize our platform. Even though it's a prototype, so I hope you guys visit and then talk about more. Then yes, if you go to the web and if you want to see the analytic reports, you can see directly from the web panel, and so that you can get the results as soon as possible. And also we give the automated reports that which we give directly from the web service. So we call this one as web-based space playground. You can request your query starting from image, or just you can bring your image so that you can run a specific algorithm. And then, yes, we do the processing on the cloud. And also, you can upload your algorithm so that we can monetize our product altogether. And then in the last stage, yeah, we do the service delivery. So by making this chain, we do our service. And then it's scheduled to open in this year, December. And then we have several items, which I told you already before, like land displacement monitoring, smart city, and also carbon MRV, and then road condition monitoring, and port management, and water extent monitoring, and crop yield forecast, and illegal building detections. So if we go on to the precise land displacement monitoring, yeah, we have several algorithms which can be adopted on here so that you can utilize, you can investigate like rural only or urban only. Yeah, we don't care about that. We try our best to investigate where you want to see it. And then this is an example of Java Island. So we make a national scale map so that we can monitor this whole island where the land displacement, the subsidence is happening. And if you go down, this is the example of Papua gold mine. So we investigated how the Papua's gold mine is subsiding. And then in the last, here we have example of Tengiz, which is in other country. They have oil field, and then by extracting the oil underground, their land is suffering from the subsidence. So we also do these kind of services. And then if we go to the next, yeah, for the B2G service of content, we also have smart city monitoring by using deep learning, especially with optical images, but also we sometimes use SAR image. So we give the statistics easily from the web, and thanks to the AI technique, yeah, we give those services like the illegal building detections or something like that. And then, yes, why SAR is so controversial these days? Since we have 24/7 operability of the SAR, yeah, it's so easy for us to use the SAR sensors in the night or where there's no light. And then it is so suitable when we are monitoring the illegal fishing or dark vessels. So that's why we have our own deep learning algorithm that we can detect the dark vessels. And then we give the statistical analysis and one-click report generation function so that you can utilize our service very easily. And also for the B2B, we regard that crop yield forecasting have big impact on the market. That's why by utilizing SAR and the others, we're making the solutions. And then thanks to our teammates, we ever won in the world first space hackathon with the idea named as iFarmer, and then that is being established. And then this solution will be coming on next year, so that we will give higher precision crop yield forecast service. And then, yes, when we are doing the radar applications, since we have an active sensor, and then it's so easy for us to detect the water. So by utilizing this, we also give the water extent monitoring. And then already one part of this service is being delivered to the one Korean research institute. And then, yes, this might be the most controversial one, the carbon MRV, which means measurement, the reporting and verification. SAR also can be utilized on this part. As you already know, carbon is really important, carbon emission, and then net zero, something like that. So we are using carbon to monitor these solutions. And then if you go down, yes, we use optical imagery to give the disaster situation recognition and optimal route guidance using deep learning. So you can see our more detailed service near our booth. And then if you go on the next, not only just giving our satellite image solution, Contact is going to launch our own satellite next year, February. And then even though it's equipped with optical sensors, yeah, we are going to extend our service so that you can access on your smartphone and then see where is the satellite at, and then what kind of mission that they're doing now, and then when they can give you the data, or you can track all your things on the web. So you can track, and then the UI will give you easy to understand. So we also expect these kind of service can be extended to the educational purpose. So the most important thing whenever we do this kind of thing is to listen from the others. I'm from engineering. I don't know about the business. And then I'm only from the hardware thing. I don't know well about the software. I don't know well how to get close to the customers. So what we are always trying to is to get in closer and then listen more and then comprehend precisely. So that's the thing what we are doing and what we are aiming for all the time. Contact and our subsidiary has a lot of customers and partners. If you can see on the right side, yeah, we have many Korean cities and also Kingwater, Kari, and Amazon Web Service, and also the satellite operators such as ISI, Apsar, Capella Space, and Synspective, Umbra, and others. Yeah, I can say we are customers and also as partners. With that, we always go out to listen more from our customers' requirements. For example, they usually say, I need more frequent analysis. And then they also say, can we get more higher resolution images? And also, yes, they would like to get more various services. And the last, they would like to have easier access. So from today, I'm going to demonstrate our prototype in our booth. But I surely say it will evolve more by listening your voice and others' voice. So I really hope that you can visit our booth and then listen about what we are doing and what we are aiming for and give us some comment. And then from here, at the Apsar, I wish that we can have nice opportunity to kick off some nice events from now on. So we would like to conclude our presentation by denoting our Richter effects. So this is a seamless satellite solutions from all around the downstream area. And then I strongly believe we can give you the cost efficiency and then we can reduce the cost which needed for this service. And also, yes, like I told you before, I really hope that we can monetize our space sectors altogether. And in the last, by utilizing this kind of space, context space studio, I would like to fuel all space industry's growth. So this is the end of my presentation, and I hope you enjoyed, and also hope that you can visit our booth just right in front of the doors. And then thank you so much for your attention.
Thank you very much, Dr. Hemian. Very interesting, very attractive presentation, and very clear for us. And the last presenter, please, Dr. Adriano Meta, CEO of MetaSensing. Please give applause for Dr. Adriano Meta. Okay, your time is 20 minutes.
Good morning to everyone. Good morning, and yeah, I am Adriano from MetaSensing, and I will be talking today about our company, which is focused on radar, particularly on synthetic aperture radar. I would like to thank the previous speaker, which lent me the mouse. And what we do, I mean, we are a company focused on radar and synthetic aperture radar. As the name says, and just probably, I am the founder of this company, and we do a number of we focus on the synthetic aperture radars, doing several aspects of the food chain, basically from the hardware design to the algorithm development to the implementation of hardware, installation and operation as well. Of course, with a number of partners. Our focus is always synthetic aperture radars and international cooperation. It's something like now 15 years that we are actively working in as a company, always steadily growing. Without investors, our only investors are our customers, because that's what we focus on making very good hardware systems and distributing around the world with partners. And basically, we were born in 2008 within the incubation program of the European Space Agency in the Netherlands, and then we grew up with opening offices and development center in Italy, then Singapore, entering certain kind of markets like airborne defense, up to arriving to satellite hardware development. Where are we located in Europe? We are located in the Netherlands and in Italy, particularly in Milan and the south of Italy, Cassino. We have some aircrafts, we do productions, both for ground-based systems, airborne systems, and satellite-based systems. But we are not only in Europe, we also have an office in Singapore, particularly for the Asian Pacific market. First for business development, and now also becoming a technical center for development and support. The radars we do can go from the ground-based systems like system for the production monitoring lines to small drones, larger drones, larger aircraft, up to satellite system. In the I'll show you some examples of airborne system, both for commercial and mapping application, defense application, going then to satellite systems, and some processor and simulators. If we look at the airborne system, that's what how we were born. The company started in order to make airborne system which could be used easily in a number of platforms. And nowadays we have mounted such a kind of systems everywhere around the world. On both small platform, medium platform, larger platform. So different kind of airborne aircraft, up to more or less almost 50 kind of different. You can see some small drones, small Cessna, helicopter, up to arriving to an Orion P3 from operated for the NASA. And this is the kind of a commercial system. For instance, installation on one of our aircraft with a belly, with a hedge, belly radar, some other larger installation with 3-axis stabilizer, different navigation systems, all number of antenna underneath the fuselage. All of them, of course, are controlled with some real-time software with feedback, so the operator can know what the system is doing, and can guide the pilots to follow the tracks. We have also our aircraft which we use it for mapping, but mainly for demonstration developments. So large belly pod, which can be used for a number of installation applications like scale events, basically all the bands that we have been operating. We have a number of other installations in with SDC or EASA certification in the nose, in the belly, underneath the wing. So there are a number of different installations which we have carried on in the last 15 years. You can see also some of the smaller systems installed on drones, which actually are being operated here in the also have a lot of experience in multi-static acquisition. So we have developed and operated and processed data acquired by multi-static sensors, where you can have a sensor installed on a platform, a sensor installed in different platforms, and collect data simultaneously in order to make bi-static acquisition, interferometric acquisitions, and so on. I have a number of slides, a lot of slides with different kind of images, but just to give you an example of the kind of SAR images that we do basically in all the different bands. Everything you see here has been produced with our system, processor, acquisition, and operation. The X-band images, L-band, C-band, interferometric angles, images, and so on. This is an example of polarimetric bistatic image with pulse-to-pulse switching from an aircraft to another one, which can also be used, of course, for terrain characterization and digital elevation model. Here you see L-band images, all full polarimetric, which we acquired for a number of customers in Italy in this case. Other examples of images which are being used for water leakage detection. And you can see also the different kind of campaigns that people organize with our aircraft, with rented aircraft, but also with partners. We can provide the sensors as something that we sell because we produce and sell sensors, but also in partnership with other partners around the world, which can use our sensors and acquire data and retrieve information like classification, terrain classification, mapping, digital terrain model, and digital surface model. Here we can see, for instance, an example of P-band acquisition, so a P-band is low frequency, which can penetrate forest and terrain. And we have an example of tomographic polarimetric acquisitions. This has been done in Germany. And from there, you can derive a digital terrain model with tomography and repeat path interferometry under the forest, under woods, and all other kind of vegetation which can be penetrated from lower frequency. We can use also C-band systems, which we also produce like Apsar family, where you have not so much penetration, of course, as L-band, P-band, just a little bit, but you can still see something. And these are mapping that we have been doing in Norway and Sweden for characterization of forests. Again, another example of interferometric acquisition for digital terrain model and digital surface model at X-band. And of course, we can go up at X-band, Ku-band, and Ku-band. These are examples of digital elevation model retrieved with X-band single pass interferometry, where we have more antennas installed on the same aircraft. Example of high resolution X-band images, we go up to 1 gigahertz bandwidth, and you can see two things here, that the system is very well phase preserving because we have to see the good quality of the image, and those are images acquired with aircraft, and differently from the satellite, which is very stable, the aircrafts are always bumping and moving, so you need to do a lot of corrections there. But as you can see from the images, all those corrections are properly implemented. Also there, polarimetry, different screens, different angles. I mean, those systems are very versatile. We also have systems at higher band, so starting from the very low band up to the 35 gigahertz, covering 14 channels, interferometry, along track, cross track, polarimetry, because we have a number of simultaneous receiving channels. In this case, 8 receiving channels. Other particular missions with systems that we have been developing and operating for the European Space Agency, and so on. So you can see how those instruments are very versatile. They use different parts of the world, from different kind of institutes, private clients, governmental agencies. And I'll go a little bit more into two kinds of systems which I use more for security applications. Which is the difference with respect to the commercial system is that those systems are much more ruggedized, shock, vibration, protocols. We use here NATO standard protocols, and also they have a kind of real-time processing for imaging, ship detection, GMTI, as we will down. This is an example installation of simultaneous X and P-band installation, what for penetration into the forest and digital elevation models. In this particular case, we are interested in detection of targets. And we can see here targets which are in open field and underneath foliage. And we can detect them. Also targets that normally with optical you could not see. And of course, we can implement a real-time change detection. So you fly once, you fly another time, so you can see difference within and outside the forest. I'll show you instead some of you slides about the Guardian, which is security X-band radars, which is normally operated on larger aircrafts or drones. I mean, not small drones, larger drones which can be in operation for 24 hours and more continuously, and they mainly use for high resolution imaging and surveillance. Here you can see installation on some of the system, and the sensor itself is a highly ruggedized and integrated system, which you can see here basically is an X-band radar with 4 receiving simultaneous channels at 1 GHz bandwidth, so we reach 15 centimeters range resolution, and all with integrated real-time processing on board. We don't military-grade boards, so shock, vibration, and so on. Then you can see some of the installations on operational drones, which are nowadays operated in East Mediterranean, Middle East, Southeast Asia, Far East Asia, so in a number of areas around the world. As you can see, everything is ruggedized in UPX format. And yet to undergo, of course, a number of qualification tests, both in terms of EMI, EMC, characterization of emissions, temperature, pressure, and so on and so forth. Everything is commanded via a NATO protocol, command and control with a user-friendly interface. And you can see, these are all real-time produced images while the drone is flying around. It collects data, process images on board, and send the data to the ground in the ground control. You have strip up, spotlight, maritime surveillance, ship detection up to 200 kilometers and more. We can do ISAP tracking, so detect and select a ship and track it over. Produce ISAR images, everything here, of course, is in real time. He has a number of features like focus, man-made detection enhancing, and of course also GMTI for detection of moving targets on the ground. The nice things of drone is, of course, that you can have 24-hour persistent surveillance on the target. Those kind of development were quite. We had to put really a lot of effort because we have to design and build and produce hardware which had to undergo a number of strict qualification tests according to the mean standard and so on. So a few years ago, we decided to do the next step to bring that kind of ruggedized hardware to the next level, which was for us space qualification. So we started design and manufacturing of space-grade boards like antennas, digital board controller, up-down converter, TR modules and amplifiers and receiving chain. And we start first internally and then within the framework of an Italian governmental project, which was NOCTUA. And that was a very nice project where we developed all the architecture of the satellites, a phase active array satellites, which allowed us to do all the kind of imaging modes, beamforming, beam steering, high resolution without mechanical movement, and also allows us to have a scalable system. So once we have built those building blocks, which are the amplifiers, the antennas, the up-down converter, and so on, then we can build different kinds of payloads which adapt to the needs of the clients and what the platform can offer. So we can have larger payloads for larger satellites and smaller payloads for smaller satellites. And this is because in a phase active array system, the design is modular by definition. This led us to be selected for the Italian governmental Iride constellation, where the country is building around 78 different satellites operating in hyperspectral, optical, thermal, and synthetic aperture data. So we signed early this year a contract for 1+1 satellite with some almost a total around 750 million budget. And award the corporate process, we say, early this year. And the nice thing which I would like to underline is that within this constellation, only Thales Alenia Space is providing satellites, SAR, and MetaSense is the payload. So there's been for us a very nice recognitions. We are very proud of those such a kind of conference event. And so what we are building is a phased active array systems. Now we build everything and we are in the qualification stage. The satellite is being integrated next year. And here we have, the antennas with more than 1 gigahertz bandwidth is a patched array. We have 32 center of phase in elevation and 1 every 10 centimeter in azimuth, which means almost 40 degrees steering capability in elevation and around 10, 12 degrees in azimuth, which also means particularly very high resolution spotlight images without the need of moving the platform. And this allows us to have very high resolution continuous images continuous. With a mechanical system, if you make a spotlight, you cannot make another spotlight just a few kilometers after because the satellite has moved. With electronic steering, of course, instead you can do that. You see the space amplifiers, 1 gigahertz bandwidth here as well. And the different modes, spotlight, street map, TOPSA, SCANSA, I mean, you name it, and those are all implemented. All the system is calibrated internally with PM gating calibration, both for single channel and dual channel. And here you can see a number of details about the imaging modes, particularly, I mean, the high resolution modes in Spotlight, which allows us to go to 15 centimeter in slant range and 13 aspect. We do not only do governmental systems, but we also do smaller systems for a constellation of smaller cells. So, more or less in the same period this year, we started a collaboration with Galaxy, an Indian company, which is a building system combining optical and SAR, and we are providing the SAR payload. Of course, here the system needs to be smaller, so the budget, the mass needs to be lower, and we implement also here a kind of active phase array architecture, but we have to use different technologies. So we developed software guide antennas with 500 megahertz bandwidth because we need a more concentrated amplifier and more efficient antenna, and that has been done. Those are the amplifiers with 100 watts output power that expand, again 1 gigahertz bandwidth, and there's also space gray. Of course, a satellite is just part of the solution, I mean the payload. Then you also need a processor to be developed for processing such a kind of use. And we developed a particular kind of processor which can process all the kind of different imaging modes. So the same processor can do spotlight, street map, scans, and whatever, but in single pole, multiple, and then it derive all the different kinds of typical SAR image products. And it comes both as a standalone solution, but also as an API solution which can be implemented in a cloud and maybe integrated inside a software architectural services as the one, for instance, presented by the previous speaker, and provide the results which can be used by the final customer. Here, those are examples of images produced by the processor we developed and compared with the official space agency, European Space Agency process, and the results are basically exactly the same. With the difference that we can process the same kind of images more or less in 20 seconds. So it's very, very high improvement from that point. And so the steps, you start from the raw data up to the final. Here, I'll just show you a few examples of images. Of course, these processors being tested with a number of satellite data. We can show the for nice things about that is that it can generate the remote is an example of Apsar. You see there's no artifacts whatsoever. But nice thing is that it automatically generates interferometric images, and therefore you can use it without any additional post-processing for digital elevation models retrieval or differential interferometric processing for the INSAR and the formation monitoring. And you see an example of two repeat passing, multi-pass results. Finally, I would like to spend a few words about simulator, which we use both for space applications and for artificial intelligence training. So it's a simulator which starts from background data and target modeling. It does all the electromagnetic softwares, and based on that, it generates and simulates the raw data, different frequency and polarimetries from for airborne scenarios, satellite scenarios, and it generates then the images which can be labeled both in the raw data and in the final. Those, of course, are then used for training artificial intelligence networks for automatic target detection. We are providing thousands and thousands of these images in different scenarios like harbor, airports, urban area, rural areas with hundreds and hundreds of different kind of targets. And we have used those for also our AI processing, which will be implemented and installed on our first satellites. You can see just a few examples here, maritime targets, the kind of targets for ship detection and tracking, of course, tanks, launcher, so many different kind of targets. And once you simulate it, you can simulate with all different angles, and that is the input for your automatic detection frame output. And different factors. Okay, so this has been a little bit what we have been doing so far at Metal Sensing. I would like to summarize just in a few points. Metal Sensing is an established company doing synthetic aperture radars. We are really focused on that, and we do only that. We are highly focused company. We are not a big multinational company, but that means that we can really focus, be agile, versatile, and we especially work collaborate with different kind of entities. Collaboration, international collaboration is our driving factor, and has been so far for all the systems that we're doing. So we believe that our 15 years experience and our also local presence here in Singapore, both for business development and now also for technical support, we can be a good partners with a number of sensors. Airborne sensor for mapping applications, airborne sensor for security applications with the penetration capability and high resolution imaging, and of course with the satellites and payloads that we focus on. Payloads and on the processors, we can be a good partner with the satellite platform producer, final user, and then a company providing the added value products with, for instance, using our processor. And from the Metal Sensing side, I would like to thank know more about what we are doing. You are more than welcome to pass by to our stand. And also, I would like to thank the few speakers for the mouse. Thanks.
Okay, thank you very much, Dr. Adrianometa, for this thing. Very useful and very clear for us. Ladies and gentlemen, all presenters already present. The presentation very interesting, very inspiring. And for any information, you can come to the booth in the other side. And you can ask everything and more, explore, and hopefully can work together for implementing and improving for our activity. Again, thank you for all. And this session is finished. And time return to Ms. Rika, please.
Thank you, Dr. Sani Darmawan. And once again, please send all the speakers big applause. And we would like to invite again all the industrial speakers to join with us to the stage again. And then from BIG, Dr. Ade Komara Mulyana, and then from Contact, Dr. Kim Yang, and then from Meta Sensing, Dr. Adriano Meta, and our moderator, Dr. Soni Darmawan. Please come to stage again because we have a gift for you. And then we would like to invite Professor Josaphat Tuko Sri Sumantio. Please join us to the stage to hand over the token of appreciation for the industrial session to all the speakers and moderators.
Ya. Oh, gitu.
Once again, thank you. And once again, the Apsar and iCare 2023, sponsored by MetaSensing, Geospatial Information Agency of Indonesia, Contact, Next Way, and also supporting organizer by IEEE GRSS, IEEE Indonesia Sections, IEEE GRSS Indonesia Sections, IEEE Communication Society Indonesia Chapter, Indonesian Society for Remote Sensing, and Chiba University. Well, ladies and gentlemen, let us start the official opening ceremony of the 8th Asia Pacific Conference on Synthetic Aperture Radar or Apsar and the IEEE International Conference on Aerospace, Electronic and Remote Sensing Technology or iCare 2023. The National Anthem of Indonesia. Ladies and gentlemen, please rise. This will be led by the video in the monitor. Singing the National Anthem, Indonesia Raya. Thank you. Please be seated. Ladies and gentlemen, next is welcoming speeches and remarks from our honorable guests and the organizing committee. I'd like to invite first, let's welcome General Chair of the 8th Apsar 2023, Professor Josaphat Tetuko Sri Sumantyo. Please, to Professor Josaphat, the time is right.
Good morning, everybody. I hope all of you can enjoy our symposium. Okay, the Honorable Head of the Research Organization of the Aeronautics and Space National Research and Innovation Agency, BRIN, Dr. Roberto Seru Triharjanto, the Honorable Head of Badan Informasi Geospasial, BIG, Professor Muhammad Aris Marfai, President of IEEE Geoscience and Remote Sensing Society, Dr. Mariko Virgin, former General Chair of Apsar, Professor Yang K. Kwak, yes, Professor Sun Yun Woo, Professor Ki Yaksi, Professor Jiang Ki Wu, Professor Akira Hirose, and Professor Jian Yu Yang. The Honorable Chairman of IEEE Indonesia section, Professor Kamantio, but now is the representative Professor Lina, yeah. Chair of the IEEE RSS AES Indonesia section, Dr. Arifin Nugroho, yeah. Chair of the Indonesian Society of Remote Sensing, Dr. Apsar. Thank you very much. Yeah. And the General Chair of the ICARES 2023, Dr. Ing Muhammad Mokayadi. Thank you very much, yes, for your comment. And leader and co-leader of IEEE Instrumentation and Future Technology Technical Committee. Here is Dr. Pedra, yes, and also Dr. Selangelo. Thank you very much for your coming. I hope you can enjoy in Bali. Yeah. Okay. The honorable keynote speeches and plenary talk from BRIN, NASA, DLR, BIG, ISI, and Chiba University. And my lovely committee member, I think I am very thanks to all of you because your great effort to realize this symposium. I think it's after the aftermath of this Corona. This is our first Apsar 2023. The honorable sponsor, Mita Sensing, yes, Dr. Mita, yes, thank you very much. Yes, and contacts, our alumni is Dr. Hin. Yes, thank you very much, Dr. Hin. Yes. And also BIG, here is Professor Marfai, yes, and also the next week, yes, Dr. Takim. Distinguished guests, participants, ladies and gentlemen. Welcome and thank you very much for your participating in the 8th Asia Pacific Conference on Synthetic Aperture Radar, or Apsar 2023. Apsar is the international conference devoted to the synthetic aperture radar, or SAR technology development and application, and sponsored by IEEE Geoscience and Remote Sensing Society, or GRSS. The Apsar is a forum for the SAR engineer and scientists for all over the world, yeah, and especially from the Asia Pacific region. The biannual Apsar conference is held every 2 years in China, Japan, Korea, Australia, Singapore, and Apsar 2023 is being held in Kuta, Bali Island, Indonesia from today, 23 until 27 October 2023. Since the COVID-19 outbreak in 2019, the committee member, in our case, is our committee, is decided the Second, yes, Apsar 2021, yes, we held a virtual, yes, international conference on 1st to 3rd November 2021. Yes. And today, yes, it is just aftermath of the COVID-19. Yes, we decided to arrange the offline only, yes, to tighten our community again, yes, by face and to face, yes, meeting, yes, because we miss each other, yes, especially I miss all of you, yes, to come here and then please meet, and I think I hug many people. I enjoy this meeting, and yeah, I miss all of you. Yeah. The Apsar 2023 collaborate with the IEEE GRSS Instrumentation and Future Technology Technical Committee. Here is Pindra and also Michelangelo and by myself. Okay? To promote the advanced remote sensing technology for the future, is our future. This conference is jointly hosted with the 2023 IEEE International Conference on Aerospace, Electronic and Remote Sensing Technology, ICRES 2023, and sponsored by the IEEE AES and GRSS and IEEE ComSoc Indonesia section. Yeah. The committee thanks very much for the continuous support of the patron. Here is Meta Sensing, Contract, BIG, and Nextwave. Yes, and also all of the sponsors, IEEE GRS, Chiba University, MAPIN, Indonesian Remote Sensing Society, IEEE Indonesia section, Common General Chair, Steering Committee member, International Advisory Committee member, and reviewer to realize this Apsar 2023. In this offline conference, yes, we consider strengthening our community by 15 minutes of the presentation. Yes, for each presenter, and 10 minutes of discussion. Yes, please make the discussion as active as possible. We will evaluate the number and quality of the question. Yeah, from each participant to evaluate for the best participant word. Yeah, I think it's this word is the first time. Yeah, please ask as much as possible. Yeah, I will count of your and also from the chair itself, yes, please manage your session as best as possible. Yes, when you have the opportunity, yes, to receive the best chair award. Yeah, okay. Of course, we also prepare the best paper award and also best presenter award, and also on the student. Yeah. In this chance, I'm deeply grateful to all members of this committee who worked hard to realize this symposium. Yeah. I'm proud and honored to work with all of you. Yeah, and it's not my conference, but it is your conference. Yeah, all of you. Yeah, and after the symposium, all participants, please don't miss to submit your full paper. Yes, to the special issue. We prepare the special issue of this Apsar 2023 in the IEEE Journal of Selected Topics in Applied Earth Observation and Remote Sensing, or JSON. Yeah, scheduled on January 1st until June 30. Yes, please submit your full paper. Yeah, and let's build Apsar to be the home of people to share the knowledge and learn of the SAR. Yeah, or synthetic aperture radar. The committee hopes all participants can enjoy the meeting during the Apsar with the Balinese cultural and atmosphere. And also one of the announcement, yes, it is from the committee. After this conference, yes, for all presented, yes, you must present. If you don't prepare or you don't present your paper, we don't upload to the IEEE Explorer. It is the rule of the IEEE Explorer. So for all presented paper, our publication chair will email you for the final adjustment of your paper if required to comply with the IEEE formatting. Please adjust with the IEEE formatting and styling, and also about the similarity before submitting it for the inclusion in the IEEE Explorer digital library. So for the simulator, it's please less than 30%. Yeah, this is I think it's the rule of the IEEE. Yeah, because we found yes, but 30% paper is still more than 30%. Yes, please give the attention for it. Okay, finally, I want to say that please enjoy networking with your colleagues and new friends during the Apsar 2023 in offline session. Yes, I will all of you. Yes, thank you very much for the time. Yes, have a good one.
Thank you very much, Professor Mustafa. And the next, let's welcome General Chair on the IEEE International Conference on Aerospace, Electronic and Remote Sensing Technology 2022, Dr. E. Muhammad Wokayat.
Good morning, everybody.
Morning.
Excellency, General Chair, Apsar 2023, Professor Yusuf Mantio, President of IEEE, Dr. Fariko Tujin, Head of Geospatial Information Agency, Bapak Professor Aris Manfai, President of IEEE Indonesia Section, Professor Gamantio, Chair of IEEE Indonesia Section, AESS, GRSS, Twin Section, Dr. Arifin Nugroho, Director of the Chandra Chiba University, Dr. Katsumi Apsar, Honorable Speaker, ladies and gentlemen, esteemed colleagues, and distinguished guests, it's my honor and privilege to welcome you to the joint opening Apsar 2023 and ICARS 2023. So 10 years ago in 2013, when we held the first IEEE International Conference on Aerospace, Electronic and Remote Sensing, we will conduct several successful conferences which are always published in IEEE Explore. As the general chair in this conference, I'm delighted to witness the convergence of pioneering ideas, cutting-edge technologies, and collective wisdom of experts from around the world. In this event, there were 64 people from 10 countries submitted to the committee, of which after rigorous review, 64% were selected to be presented in this event. The topic we aimed at in this conference have illuminated the boundless possibilities and opportunities that aerospace, electronic, and remote sensing offers to our day. We have explored the trend and advance in space technology, investigating into miniaturization, implementing data science and artificial intelligence in remote sensing, all of which are grasping the way forward. In this discussion, we have witnessed the transformation of aerospace electronic from large, complex systems to agile, cost-effective, and highly capable small satellite missions. Furthermore, our discussion in this conference talks the complexity of transmission in small satellite constellation. We explore the potential of this mission to drive innovation in space science, to safeguard our planet, and to foster collaboration among space agencies, research institutions, and private companies. This conference exemplifies the power of interdisciplinary collaborations, where researchers, engineers, industry leaders, and policymakers come together to shape the future of aerospace, electronic, and remote sensing. As we proceed with our conference, I encourage you to engage in thought-provoking discussion to forge a new collaboration in the pursuit of innovative solutions. I extend my deepest appreciation to our distinguished speaker, our invaluable sponsor, and all participants who have contributed to the success of this conference. I wish you all an inspiring and productive conference, and I hope you will enjoy sharing the knowledge and science and technology in Apsar and ICARES 2023, and enjoy the conference with the atmosphere of Balinese culture. Thank you.
Thank you for the welcoming speech for Dr. Mukayati. And the next, we have General Co-Chair and Technical Program Committee Chair of the Apsar 2023, Dr. Agustan, to deliver his report. To Dr. Agustan, the floor is yours.
Bismillahirrahmanirrahim. The Honorable General Chair of the 8th Asia Pacific Conference on Synthetic Apsar Radar for the 2023 Apsar, Professor Josapat Tetukosris Mansum. General Chair of the 2023 ICARES, Dr. Engineer Muhammad Mukayadi. President of IEEE GRSS, Dr. Mariko Burdin. Head of the Geospatial Information Agency, Republic of Indonesia, Bapak Profesor Haris Mafai. Bapak Dr. Bertus Heru Triharyanto, Chairman of the Research Organization for Aeronautics and Space, BRIN of Indonesia. President of IEEE Indonesia Section, Professor Gamantio Hendrantoro, represented by Professor Nagzi. And then Chair of Indonesia, IEEE Indonesia Section, ISS, GRSS Joint Society Chapter, Bapak Dr. Arvin Groho. Director of CRS Chiba University, Dr. Karsuni Hattori. Prominent Professor, Pak Ketut, Profesor Ito, Pak Dekomara, keynote speakers, distinguished guests, participants, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. Very good morning. Ohayou gozaimasu. Om Swastiastu. On behalf of the Indonesian Society for Remote Sensing, or MAPIN, and Technical Program Committee, we are honored to welcome you to the 2023 Apsar and ICARES that is held in Bali, one of the most beautiful islands in the world. The biannual Apsar conference is held every 2 years, and previously, in 2021, Apsar is hosted in Bali Island, Indonesia, but in virtual mode due to the COVID-19 pandemic. Fortunately, we once again are trusted to organize the 2023 Apsar in Bali with in-person meeting. We are certain that new collaborations can be created and ongoing collaborations strengthened. Ladies and gentlemen, for this event, for Apsar received 169 submissions from 19 countries and selected 82 papers. This level of international participation is indeed acceleration and encouraging. In addition, for 2023 ICARES, the acceptance rate is 64% of the 64 papers from 10 countries. These papers will be presented in 3 tracks. One is the aerospace and electronic system. The second one is geoscience and remote sensing. And the third one is the data science and artificial intelligence. In organizing this conference, we are grateful to many dedicated persons who have contributed to the success of this event. We would like to extend our sincere thanks to Professor Josapat Tetukosris Mantio and Dr. Mukayadi for their enthusiasm in releasing this conference. Technical Program Committee members and reviewers from almost 31 countries, especially for Professor Josapat, Mr. Imade Okaguna Antara, Mrs. Rika Hernawati, Mr. Hunul Kausarian, Dr. Ilham Alimuddin, Mr. Muhammad Nur Cahyadi, Dr. Yohandri, who committed their time, energy, and thoughts. We would also like to thank the organizing committee who has worked tirelessly for the conference. Also, we would like to extend our gratitude to all authors whom without their contribution, this year's conference would not exist. We hope that all the participants get useful and updated information on synthetic aperture radar and related technologies scientifically and may apply it in your activities. We are also hoping that the next conference will be attended by more participants from all over the world, especially young scientists. Thank you very much, and wassalamualaikum warahmatullahi wabarakatuh. Om Santi 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 Om. Thank you.
Thank you, Dr. Agustin. And next we have the President of IEEE GRSS, Dr. Mariko Bergin, who will deliver her remarks in online. So, Dr. Mariko, please, the time is yours.
Thank you so much. I hope you can hear me well. My name is Mariko Bergin. I'm the IEEE GRSS president, and unfortunately, I cannot be with you in person, but I am really excited that I am here with you virtually and get a chance to talk to you. So let me share my slides for a brief presentation, and hopefully it will be interesting to you to learn more about IEEE GRSS. Just give me 1 second. All right. All right, I am honored to be here, and I wish I would see all the faces in the room. Good morning to you all. As said, my name is Mariko Bergin. I'm the IEEE GRSS president, and I'm here to speak to you for a brief time about IEEE GRSS that I hope that you can consider to be your professional home. I'm very happy to be here speaking on behalf of GRSS at Apsar that you are holding right now on the wonderful Bali Island. I'm really sorry that I'm missing it. All right, let me talk briefly about GRSS. GRSS is one of the co-sponsors of this conference, and we're very, very proud to be so. GRSS is a global community, as I like to say. We were founded in 1961, and we're going strong. So we have quite a bit of heritage. We are one of 39 IEEE technical societies. And as you can see here in the mission statement, we fostered engagement for the benefit of society through science, engineering, applications, and education related to geoscience and remote sensing. What I think is very important about GRSS, and as we can see in your conference as well, our field includes theory, concepts, and techniques of remote sensing of the Earth, oceans, atmosphere, and space. And then, of course, all the processing, interpretation, and dissemination of this information as well. So it's a very broad field, which means there's a lot of interchange between different people, different subspecialties. I think this is really an excellent thing about geoscience and remote sensing. We currently have more than 5,000 members in 144 countries. And on the left, you see we are governed by the IEEE GRSS Administrative Committee that I spearhead. And at the bottom, you see we currently have 128 chapters, so 73 regular chapters and 55 student chapters, and 12 ambassadors all over the world. And this is something not to forget. We are a global community. We have GRSS chapters everywhere. So I am very happy to see that 9 GRSS chapters are involved in co-sponsoring this society and organizing it, ranging from, of course, the joint Indonesia chapter to the Japan chapter, the Singapore joint chapter, the Australian Capital Territory and New South Wales chapter, chapters in Beijing and Shanghai, in Seoul, Bombay, and Malaysia. I think this is really excellent, and it's really important to bring the global community together in events like you are holding. So use this opportunity, get to know new people. And one other thing I noticed is there you have several joint chapters between AESS and GRSS, which are 2 IEEE technical societies. This in particular, I think, is also excellent because GRSS is one society, but there are many others, and it's good to know who your neighbors are and collaborate and have partnerships. So here is one slide that I like to show. Who are we? Who is the GRSS membership? And you see here in the top left, sort of our distribution of how many members we have over the year. You see also the numbers if you prefer to see it in table form. And then some few statistics in the pie charts that you see. We have about, at the end of August, 5,100 members. We have 18% female members, and that's something that we're working on to see, like have more representation. And we have 12% female fellows. And when you look at the right-hand side, you can also see we have participants or members from academia, industry, and government. And we have various levels of members, starting from student members to senior members to members and all the way up to fellows. And this is my moment when I wanted to shout out to you and say, become a senior member. It is very possible that you already qualify to be a senior member. You have to be active in the field for 10 years. So if you are a member and you have been with GRSS or been in the field for 10 years, consider joining. There's some additional benefits that you can get as senior member. And I think I would be happy to also be helping you with your senior membership. We have a whole senior membership search committee, and we would love to help you to become a senior member and take even more advantage of your society membership. One other thing I definitely want to highlight is our premium science. I'm always astonished when I see this slide, because you can see how many publications GRSS curates. We currently have 4 sponsored publications, TGARS, GRSL, JSTARS, and GRSM. Then we have 2 co-sponsored publications, JMAS and Transactions on Radar Systems. Just since a few weeks, we have now a GRSS section in IEEE Access, and we also have an e-newsletter. And this is the QR code in the bottom right that you see there. Sign up for the e-newsletter. If you're new to GRSS, or perhaps if you haven't seen the e-newsletter yet, sign up. It is an excellent monthly free e-newsletter that you get, and it basically keeps you up to date on what all is going on in GRSS, on publications, on upcoming conferences, but also on job opportunities and other things that we're doing, like webinars. Let me continue on to the technical committees. I hear that several of our technical committees are also involved in this conference. So you might be familiar with this. We actually have 8 different technical committees, and you can see they span a wide variety of topics, from earth science informatics to frequency allocation and remote sensing, to standards, to imaging spectroscopy, image analysis and data fusion, instrumentation and future technologies, modeling, and then the newest one is remote sensing, environment analysis, and climate technologies. All of these are enormously engaged and an excellent starting point to get engaged in our society. All of them have their own sort of e-newsletter, their same group. So if any of these 8 technical committees speaks to you, sign up to them. They will keep you in the loop as well, and get engaged. They're really a great way of engaging with your specialty and getting to know other experts in the field. On the bottom here, I have another QR code, because we also have a podcast. GRSS has a podcast called Down to Earth. I think we're now in season 4, if I'm not mistaken. The technical committees have just organized one that is finished, and I highly recommend the Down to Earth podcast. It's a podcast for geoscientists by geoscientists, and even for people who are not directly in our geoscience field. They say it's very interesting and engaging. Highly recommend it. Then the other thing that is very important about GRSS, and I think speaks to the global community, is we're providing connections and networking. You are aware of our flagship conference, IGARS. We just had our IGARS 2023 in Pasadena in July, and you see some of the statistics here, and we look forward to the one in 24 in Athens, and then IGARS 2025 in Brisbane, Australia, usually always happening in July, around that time of the year. Then we also have regional symposia, and you see here There's several coming up. This year we have INGARS, which happens in India. Then we have M2GARS, which happens in the Mediterranean Middle East. And then LEGIRS, which is in Latin America. And here is our full list of co-sponsored specialty conferences and workshops. And I'm not remiss to highlight Apsar. We're very happy that you are also one of the co-sponsor conferences. And I'm very glad to be here. And you can see there are many other specialty conferences and workshops that GRSS also supports. And I think really this is part of the work that we are supposed to do to support our community, to meet, to network, and to present their work. Now, one other thing that you might not know as much about are our professional activities. So if you are a chapter, there is, for example, an Indonesia chapter, but also other chapters, you can invite distinguished lecturers to come by and present. And for example, here you see a few biopics of a few distinguished lecturers. Excellent speakers, excellent topics, highly recommend that. Then also we have a very active young professionals group. You can see here some of their works that they're doing, for example, at IGARS, Earth at Risk Image Contest. They have mixers, they have a 3-minute thesis competition or an elevator pitch challenge. If you're interested, take a look at what the young professionals team is doing. There's some really great initiatives in there. And I think also things that could be replicated at a conference or perhaps at a chapter. Then we have the IDEA Committee, which stands for Inspire, Develop, Empower, and Advance. And in there, they do many different things, but 2 things I wanted to highlight are a $500 professional development microgrant system. So if you're a GRSS member, you can apply to that for your own professional development. And then we have the Women Mentoring Women program. It's a program that was formed several years ago, and that's really supposed to encourage our female scientists, engineers, and practitioners to stay engaged in the field, to get a little bit of extra mentoring. And so if you're interested, take a look at the website, and also let me know if you have any questions, because I'm very happy about these programs, and mentoring in general, I think, is extremely important. All right, then about our learning and other opportunities, as I call it. Our education portfolio is very big, and I'm just mentioning here a few things. You can see really we have GRSS schools, which are in-person schools all around the world, but we also have a very interesting webinar series. So if you're interested to tune in from home, don't have to travel, check those out. There's some very excellent speakers going there as well. Then we have a high school and undergrad student outreach program. We also have student grant challenges. There's just a 4-student grant challenge got started. That's also something, if you are a professor or if you're a student, consider looking into this. It's a really interesting challenges. A previous challenge launched their own CubeSat. Another one was looking for marine debris in the ocean. Excellent opportunities to get engaged and really do something in the field. Then we have travel grants, and we also have a Coursera course on remote sensing image acquisition, analysis and applications. We already have more than 12,000 learners. That's something you can take online. All part of education that GRSS is trying to provide. So I'm already coming towards the end of my presentation. I know I only have a few minutes left, but I wanted to leave you with a few thoughts. I really think GRSS is a community of communities. A previous president has coined this term, and I really like it because I want GRSS to be your professional home. It's a place for technical excellence, but it's also a place where you are welcome and you belong. And I think most importantly, it is a place that you can make your own. So really a place that you become active in. If you're in a chapter, try to become active and shape it, because that's really how you give back to the community. And I think in the end, we all want to make a difference in the world through remote sensing. So finally, this is an invitation to join our community if you have not yet. It's really an excellent way to share and promote your ideas, meet with other communities, build collaborations, learn from each other, and also work with like-minded researchers and developers. And I leave you with a QR code, and I just wanted to say I wish you an inspiring conference, and thank you so much for having me today.
Thank you so much, Dr. Marika. And then next we have the greetings will be delivered by President of IEEE Indonesia Section, Professor Gamantio Hendartono, and will be represented by the Secretary of IEEE Indonesia Section, Professor Linawati. To Professor Linawati, the time is yours.
Dear distinguished guests, colleagues, researcher profession, ladies and gentlemen, I will represent here Professor Gamantio, who cannot attend this conference because of he has another duty. So on this good occasion, I will read his speech to all of you. Good morning, warm greeting to all of you. And first of all, please allow me to extend my warm greeting to the Honorable President of IEEE GRS, Dr. Mariko Bunjin, that I already heard her speech just now. And Honorable Head Orpabrin, Dr. Robertus Heru Triharyanto, Chair of IEEE AESS GRS Indonesia Chapter, Dr. Arifin Nugroho, selamat pagi Pak. And Director CARS Chiba University, Professor Katsumi Hattori, good morning. And of course, the General Chair of the Apsar 2023, Professor Yosafat Tetuko-Sri Sumantio, yeah. As well as the keynote distinguished and invited speaker, Dr. Robertus Heru, Head of the Research Organization of Aeronautics and Space from BRIM, Dr. Upendra and Singh from NASA Research Center, Dr. Michelangelo Milano, Head of the New Space Sub Research Group, Germany, and Professor Muhammad Aris Marwai, Head of Badan Informasi Geospatial, Dr. Oscar G. from ICE YE Finland, and all of the industrial speakers who already shared their knowledge this morning. And last but not least, to the conference committee members and all participants. Ladies and gentlemen, on behalf of the IEEE Indonesia Section, Prof. Gamantio, I would like to extend our warm welcome to all keynote speakers, presenters, and participants to the Apsar 2023. This conference is jointly hosted with the 2023 IEEE ICARES, International Conference on Aerospace, Electronic, and Remote Sensing Technology, and is held in hybrid mode by collaboration of the more than 7 or 9 chapters of the IEEE, AES, and GRSS. It is supported by more than 5 universities in Indonesia, such as Institut Teknologi Bandung, Universitas Gadjah Mada, Institut Teknologi 10 November, and also more than 2 universities in Bali, such as Universitas Guyana, Universitas Mahasaraswati dan Pasar, and Universitas Pendidikan dan Desa. This conference, Apsar 2023, is an international conference devoted to SAR technology development and application, and is a forum of SAR engineers and scientists from all over the world who wish share and discuss the newest knowledge and technology on SAR during the conference. This conference, of course, is to boost our network by finding new friends and colleagues during the conference, and to extend to, expand the existing networking, and to promote research to contribute to the technology and application of the SAR, especially the monitoring of disaster and environments that fit well with the primary theme selected by the IEEE for 2023, namely climate change. With technical tracks in the conference covering the area of SAR and radar system, SAR application, SAR image processing, etc., the instrumentation and future technologies are moving target and detection, all of which perfectly belonging in the technical scope of IEEE. We can expect a good share of contribution through the technical papers presented in this conference in the form of innovative ideas towards the achievement of the Sustainable Development Goals, including solution to the climate change problem. Ladies and gentlemen, I would like to share briefly about the IEEE Indonesia section itself. The IEEE Indonesia section have carried out a large variety of activities over the 35 years of its operation in Indonesia. Our mission is in line with the global mission of IEEE, namely advancing technology for humanity, which is, in our case, is adapted to the condition and necessities of the people in Indonesia, while still contributing to the mission implementation internationally. We maintain good and mutual relationship and networking with the Indonesian government, industry, university, professional and scientific organizations, and various communities in Indonesia. At the same time, we are also starting to work together with other IEEE sections in the Asia Pacific region. We have had a cooperation agreement with the Director General of Higher Education since 2021, which allows us to directly participate in the development of engineering higher education in Indonesia. We are also developing cooperation with professional organizations as well as universities in Indonesia. Currently, we have 21 technical society chapters and joint chapters covering the field of interest of 27 IEEE societies, widely ranging from power and energy to computer, oceanic engineering, education, social implication of technology. This chapter supports various scientific and academic activities in Indonesia, including technical co-sponsorship of this international conference. Now we have student branches and student branch chapters in 36 universities in Indonesia. It's a quite good development of IEEE Indonesia section to encourage all the students to join, become a member of member of IEEE. The student branch and student branch chapter will support educational and early career development and international networking for university students. We would like to invite all universities in Indonesia to establish IEEE student branch at their campus and maximize the potential benefit of talent and skill development for students through IEEE, as we already heard from the president of IEEE GRS. And aside from that, we also hold many workshops on STEM for high school students in our attempt to attract the best talent to study in the field of engineering. In terms of international publication, according to IEEE Explore, as of August 2023, there are almost 30,000 scientist papers in IEEE Explore, with at least one author coming from Indonesia, published in IEEE co-sponsor conference and IEEE journal. However, out of those 31,000, there are still less than 1,000 papers, at least one Indonesian author published in high quality impact IEEE journal. Accordingly, we encourage Indonesian researchers to publish their works in relevant IEEE journal. To conclude this remark, we highly appreciate the commitment shown by the organizer of Apsar 2023, led by Professor Yosafat, to keep the quality of accepted paper at the highest level, focusing only on paper within the scientific scope of the IEEE and the conference. Finally, we wish you enjoyable and valuable experience during this event by sharing your best knowledge in the research area of your interest. Have a good day and enjoy Bali. Please make Apsar 2023 a memorable event. Thank you very much.
Thank you, Professor Rinaldi. And then next we have the chairman of IEEE GRSS or AES Indonesia section, Dr. Ing Arifin Nugroho, DEA. So Dr. Arifin, please, the time is yours.
In the name of Allah, the merciful and the compassionate. Dear professors, authors, colleagues, ladies and gentlemen, it is delightful to see that these two international conferences, the Apsar 2023 and the ICARES 2023, could be held physically in Bali Island. Please welcome to enjoy the tropical atmosphere in these charm spots of the island with foods, music, dances, and people, the things which, even for the locals such as us, are always longing to re-experience again and again. On the other hand, as a professional in the remote sensing and aerospace electronics, we are also excited to be gathered here to see the dearest colleagues in the same and or across the domains of expertise, to be able to exchange views, methods, new algorithms, and their application in its engineering developments in the above fields, including, of course, SAR. We are very proud and grateful to have the maestros from across the globe who will share their keynote addresses and information novelties in multitude of subjects in the above intertwined fields. We are all happy to have 82 papers to be presented in the Apsar 23 and 41 papers in the ICARES 23, which all will contribute to the literature enrichment for research references in the SAR, remote sensing, and aerospace electronics. We should congratulate to both Apsar and ICARES committees for such excellent and concerted jobs in making these conferences run. The high appreciation should go to the general chairs, vice general chairs, general co-chairs, vice general co-chairs, technical program committee chairs, technical program committee co-chairs, technical program committee members, steering committee members, publication chairs, and organizing committee members. High apprehension should be dedicated to the sponsors, technical sponsors, co-technical sponsors, and supports, without which these events can hardly be executed. The very special thanks should go to Professor Josaphat Tetuko Sri Sumantyo, PhD, our guru from Chiba University, Dr. Eng Wahyudi Hasbi from BRAIN, Professor Ketut Wikantika, PhD from ITB, Dr. Agustan from BRAIN, and Dr. Eng Muhammad Mukhayati from BRAIN, all of them amongst the most powerful and dedicated people behind the running of both conferences here in Bali. Last but not least, very highly respect shall go to the keynote speakers, authors, which serve as the nucleus of the conference's
content. Please enjoy your meeting. Thank you.
Thank you, Dr. Arifin. And last but not least, let's have a listen to the remarks from Director of Center for Environmental Remote Sensing, Chiba University, Professor Katsumi Hattori.
Thank you for introducing me. Ladies and gentlemen, dear distinguished guests, my name is Katsumi Hattori, Director of Environment, Center for Environmental Sensing, Chiba University. On behalf of the organization, I'd like to have some address in few words. First of all, I'd like to give my sincerely appreciation to Professor Yospart, the Zero Chair of this meeting, and also the Professor Gantier, Vice Chairman, and also the Federal Committee of Augusta, Professor Augusta, and for their efforts to organize AP's conference, and also appreciate the special support for the IEEE Indonesia sections, and also many bodies of the IEEE ZRS section in several countries, and also several Indonesia institute from university and institute to support the organized conference. Of course, the distinguished sponsors. The Apsar is an international conference devoted to SAR technologies, development, and application. This Apsar is forum of symposium of aperture radars, engineers, and scientists from all over the world, especially from the Asian Pacific region. Apsar conference is held every 2 years, I heard, and formerly which are held in China, Japan, Korea, Australia, and Singapore in turn. Last time it was planned to open here, but unfortunately, the pandemic of the COVID, that this is postponed, not postponed, actually held by online. But this is the event to actual in-person meeting here. So that is very good. And the atmosphere in Balinese is very, very warm, and altitude of people, atmosphere of people is very, very bright. So it's very good place to organize this kind of meetings like this. So also this meeting, internally meetings, ETS that she told, but I told ITS to some extent. I care. I for it, I don't know, but interest for ITS would be great. But anyway, eventually held here, that is also very good, I think. And so anyway, the Apsar meeting played a great important role in sustainable development of the scientific and engineering community observed in the world. And also the capacity building of young students, young scientists is very important. And ACE is every 2 years, and ACE conference it was more than 15 years. The congratulations to this kind of great opportunity, and also this kind of meeting, sustainable and progress to the future. That is a very important point. And the Apsar 2023 will be held in person international conference from 23 to 27 October here in Bali this year. I believe Balinese atmosphere will accelerate the scientific and technological activities in this field.
In this background, the Chiba University is one of the main sponsors for the Apsar Symphony since last Apsar. Unfortunately, it was not held in person. You know, our series of our center for remote sensing environment remote sensing has developed several microwave remote sensing technology, especially the CPSR circular polarized aperture radar by Apsar and for drone, airborne, high altitude platform systems, and also microsatellite systems. And we have a plan to strengthen cooperation in research and academic exchange of activities through this kind of conferences. During this conference, fruitful discussion will be done and new collaboration will come arise between person to person or between institute to institute. So that is a great chance. And I think Peru's environment, atmosphere, culture will enhance this kind of activities very much. And please enjoy your stay in Paris and expand your networking by Apsar 223. Thank you very much for your kind attention. This is my address. Thank you very much.
Thank you, Professor Katsumi Hattori. Ladies and gentlemen, now come to officially open the 8th Asia Pacific Conference on Synthetic Aperture Radar 2023 and the IEEE International Conference on Aerospace, Electronic and Remote Sensing Technology 2023. We would like to invite Professor Josapa Tetukos Risumantio, Dr. I. Muhammad Mukayadi, Professor Muhammad Arif Marfai, Dr. I. Arifin Nugroho, Professor Linawati, and Professor Katsumi Hattori to return to the stage to perform Hitting the Gong to officially open the Apsar 2023 and the ICAMS 2023. Let's get ready. On my mark. 3, 2, 1. The Asia Pacific Conference and Synthetic Aperture Radar 2023 and the IEEE International Conference on Aerospace, Electronic and Remote Sensing Technology 2023 are officially open. After hitting the goal, we would like to invite our VIP guests to come forward to the stage to take the photo session. To our VIP guests, please join with us, Dr. Agustan, Professor Linawati, Dr. Arifin Nugroho, Professor Katsumi Hattori, Dr. Upendra Singh, Dr. Michelangelo Villano, Professor Muhammad Arif Marfai, Professor Junichi Susaki, and from next way, Mr. Naofumi Takemoto, from BIG, Dr. Ade Komara, from Contact, Dr. Hin Yang, and from Meta Sensing, Dr. Adriano Meta. Please join with us to the stage for have a photo session.
Freestyle.
Hold on for a moment. Please welcome Dr. Upendra Singh
Oh.
for having a presentation with us. And Dr. Michelangelo Villano.
I was texting.
Okay, thank you. Please return to your seat.
We have another picture from here
Okay.
with the
Okay.
participants.
Hold on a moment, sir. We have
We're going to have
we are going to have a selfie with
picture
our
of the participants.
participants.
Prof, kita ambil dengan partisipan. And all participants may be.
Please, all the participants may rise to having a photo with us.
Please stand and move forward, please, if you can. You may move forward. Yeah, so everybody can be in the picture. Oke, pakai kursi aja. Pak, harus pakai HP juga.
Okay, on my count.
Want to have 2 rows here? Yeah.
I also have. I'll say it again. Okay, on my count. 1, 2, 3. Say cheese. Once again, say hi. Okay, once again, Bali. Okay, thank you so much. Okay, next, we would like to ask again to all the welcoming speakers to come to the stage because we would like to present a ceremonial gift for Dr. I. Muhammad Mukayadi, Dr. Agustan, Dr. Mariko Borgin, Professor Linawati, Dr. Ing Arifin Nugroho, and Professor Katsumi Hattori. And to present the ceremonial gift, kindly be invited the General Chair of EBISA 2023, Professor Yosabat Tetuko Sri Sumantio.
Minta Profes ngomong ya bentar ya. Dia masih online soalnya. Enggak di Mariko ini. Mau online ya. Iya, enggak. Oh, perlu kita tambahin. Iya. Boleh. Boleh. Tampilin ya. Iya.
Yeah, you can mention that for Professor Mariko.
Okay.
We also have one.
Okay, thank you very much to Dr. Mariko Borgin. Yes, for your support to the 8th Asia Pacific Conference on Synthetic Pecereda. Thank you very much. Yeah.
Thank you so much.
I will send to you. Please inform your address.
Thank you.
Okay, thank you very much, ladies and gentlemen. You may return to your seats. Ladies and gentlemen, we proudly present the traditional Bali dance Sekar Jagat. Sekar Jagat dance comes from the word Sekar, which means fragrant flower, and Jagat, which means world. So, Sekar Jagat also means the dance of flowers in fragrance garden throughout the world. The Sekar Jagat dance is a dance that depicts the beauty of the flower of the universe, namely the flower dance, which is a symbol of perfection. This dance has many beautiful movements, such as graceful hand movements, agile foot movements, and other charming movements. This dance depicts the joy of the dancer in welcoming the guest present. This dance was created by Swasti Wijaya Bandung in 1993, and his accompaniment director Nyoman Winda. Let's welcome a performance from Udayana University students, Sekar Jagat Dance.
Dengar suaranya, dia nggak dengar suaranya. Dengan saya tertawa di teman-teman lainnya dia nggak dengar. Kenapa dia nggak dengar? Oh, nggak di share ya? Oh ya, aduh. Oh, nggak share. Tapi nanti apa ulang lagi nggak? Oh, enggak ulang ya. Nggak ulang ya. Harusnya kedengeran karena apa? Yang ini kan bergema. Ya, nanti nggak dengar. Gimana caranya? Iya kalau nggak ganggu tapi ganggu di enggak jangan di-share jangan di-share. Oh, di soundnya nggak itu ya. Kalau di-share ininya muncul ya. Soalnya nggak muncul. Oh iya iya nggak muncul. Kecuali pakai ini aja. Ya, nah itu aja. Dideketin ke mic, deketin ke mic. YouTube. Enggak, saya belum buka YouTube soalnya. Ya, di sini yang open harus plastik, tapi itu story mesinnya nggak bisa dapat ide. Ya, ini kan sebelah itu ya. Iya. Jadi Ada kan? Ada tapi. Oh ya udah ada. Ada tapi kan? Kan? Pas baru kita ngobrol, kamu kedengeran. YouTube.
Once again, please give a big applause for student of University of Udayana. Ladies and gentlemen, before we move on the next sessions, let us take a short pause and enjoy the coffee break for 20 minutes. Okay, for 20 minutes, and the coffee break is at the first floor of this building. And during the coffee break, you are also welcome to attend the exhibition booth beside this room. And then for you that want to have a presentation tomorrow, you can download the technical program or the procedure book at the website of Apsar. Okay, thank you. Please have a nice coffee break. Enjoy the coffee break, and just for 20 minutes until 11 a.m. Thank you.
Oke, ini moderatornya Pak Ketua. Nanti yang Pak Robertinus Heru.
Robertinus Heru.
Ini.
Oke.
Mungkin kita kelompokkan dulu aja.
Iya, yang sekarang
Sob. Ya, Sob. Ini keynote speaker. Hai.
I'm one of the speakers tomorrow, but I was not able to load the presentation. Can I come here with a memory stick, or how can I do?
Tomorrow?
Yeah.
Maybe you can.
I can come tomorrow with
Tomorrow,
the presentation.
maybe you can.
Yeah, it's better tomorrow.
Yes, better tomorrow.
Okay, but I can.
Okay.
Because I couldn't with the system.
Yes. Ini kumpulkan.
Oke.
Itu sebutnya ini aja keynote speaker.
Ini speaker aja,
Ya, keynote speeches. Oke. Yang pertama Robert.
Oke. Betinus, oke.
Ini video aja dulu, video ini.
Video. Oh ya, Apsar.
Itunya di mana?
Terang suaranya. Kita dengerin. Iya itu.
Our agenda is to prepare spatial policies that refer to one policy, guaranteeing access to information, credible information, proper.
Itu baru.
Terima kasih Mas. Terima kasih. Terima kasih.
Satu udah kelar.
Sudah paham.
For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help you dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Contact will bring and show the space to the world. Enjoy your own space.
Baju setengah jam bagus lah. Ya, baju 15 menit, 30 menit. Oke, jam 11. Ini sofanya belum dinaikin.
For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help you dream to reach space. We can make it in space for anyone to enjoy every piece of space. Contact will bring and show the space to the world. Enjoy your own space.
Has transformed substantially from 1938 to 2011. EIT holds the roles of innovator, implementer, coordinator, regulator, and regulation, while also implementing them at the same time. Our duty is to prepare spatial policies that refer to one map policy, guarantee access to information, credible information, proper.
For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help you dream to reach space. We can make it in space for anyone to enjoy every piece of space. Contact will bring and show the space to the world. Enjoy your own space. For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help you dream to reach space. We can make it in space for anyone to enjoy every piece of space. Contact will bring and show the space to the world. Enjoy your own space.
Has transformed substantially from 1930 to 2011. EIT holds the roles of regulator, implementer, coordinator, regulator, and regulation, while also implementing them at the same time. Our duty is to prepare spatial policies that refer to one map policy, guarantee access to information, credible information. Proper.
For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help you dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Okay. We'll bring you and show the space to the world. Enjoy your own space.
Tes 1 2 3. Tes 1 2 3. Pak Wahyu Hasbi. 1 2 3. Ladies and gentlemen. Ada.
For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space, Contech will bring and show the space to the world. Enjoy your own space.
BIG has transformed substantially from 1938 to 2011. BIG holds the roles of regulator, implementer, coordinator. We prepare the data and regulation while also implementing them at the same time. Our duty is to prepare spatial policies that refer to the One Map policy. Guaranteed access to information. Credible information. Proper.
For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space, Contech will bring and show the space to the world. Enjoy your own space. For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream.
Ladies and gentlemen, check sound 1, 2, 3.
For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Contact will bring and show the space to the world. Enjoy your own space. For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Contact will bring and show the space to the world. Enjoy your own space.
BIG has transformed substantially from 1938 to 2011. BIG holds the roles of regulator, implementer, coordinator. We prepare the data and regulation while also implementing them at the same time. Our duty is to prepare spatial policies that refer to the One Map policy. Guaranteed access to information. Credible information. Proper.
For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Comtech will bring and show the space to the world. Enjoy your own space. For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Comtech will bring and show the space to the world. Enjoy your own space.
BIG has transformed substantially from 1938 to 2011. BIG holds the roles of regulator, implementer, coordinator. We prepare the data and regulation while also implementing them at the same time. Our duty is to prepare spatial policies that refer to the One Map policy. Guaranteed access to information. Credible information. Proper.
Ladies and gentlemen, our event will start again. Please join us to room again. Once again, ladies and gentlemen, the event will begin. Ladies and gentlemen, our event is about to begin. Ladies and gentlemen, welcome to Apsar 2023. And we have next sessions. We have come to the core agenda of our meeting, that is to attend the plenary talks from our keynote speaker. There are two sessions of the plenary talks today. Each session will present 3 keynote speakers. Ladies and gentlemen, the first sessions of this plenary talk will be moderated by Professor Ketut Wikantika, PhD. Please welcome Professor Ketut Wikantika.
Everyone, how are you? Okay. First of all, I would like to thanks to the committee. It's an honor to be here together with you from many countries coming to Bali to join this conference. Enjoy Bali, and you can see here that I'm wearing traditional Bali. We call it udang. Udang. Udang is made from a piece of cloth with color paintings. Actually, there are many materials can be used to make like this. Dr. Upendra and Michelle Angelo. Oh, you not wearing udang. So udang has a philosophical meaning that everyone should try to do good deeds. Udang is also symbol of togetherness, harmony, purity, patience, and also, I forget it. And also politeness in respecting differences. So, you know, Hindu community in Bali, every day wearing this such kind of udang. Okay. So I wearing red color of udang. Dr. Upendra, blue color. Matching, yeah. There is no green color. Remote sensing community can live without green color because we can create RGB color, RGB composite, color composite image without green. Correct, Pak Upendra? Okay. I'm very happy to be here again and proud to guide an extraordinary speakers from Indonesia, Germany, and US. So I would like to invite Dr. Upendra Singh. Please come to the stage. Dr. Michelle Angelo. The first speakers of this session would be Dr. Heru, but unfortunately, he is having a very urgent family business. Dr. Upendra, please take a seat here. Dr. Michelle Angelo. Michelangelo. Sit down, please. Okay. So, the committee would like to apologize for any inconvenience because Dr. Heru couldn't join us because suddenly he is having a very, very urgent family business. But he already sent his video tracking for the presentation. Before the committee delivered the presentation of Dr. Robertus Heru, I would like to deliver the curriculum vitae of Dr. Heru. He was graduated from North Carolina State University for BSc degree, and Texas A&M University for Master Science in Aerospace Engineering, and he got PhD from Bandung Institute of Technology. So many experiences he got. One of them is now currently is head of research organization of for aeronautics and space of Indonesia. So please, committee deliver the video recording from Dr. Head.
Yeah. First of all, I would like to thank the committee, Professor Josapa, Professor Gamantio, and Dr. Arifin, of course, that invited me to speak, to have the honor to speak in this conference. So my presentation today has the title of Synthetic Aperture Radar Research and Application in Indonesia. And among others, this is due to the work of Professor Josapat, that today we have a lot more SAR researchers in Indonesia compared to the 10 years ago. So first of all, also I would like to apologize that I could not be there with you in person. I have to attend some family emergency, and we guess we're gonna start. So on the left, on the left top is the image data given to me by the late Dr. Anggoro from Ministry of Maritime Affairs and Fisheries in 2017. During that time, there was a grant from French government of using SAR technology and VMS technology to catch the illegal, to detect the illegal fishing in Indonesia. So the synthetic aperture radar satellite, RadarSat at the time, scan all the ships, while the VMS systems screen the ships that transmitting its identity. When you overlay the two data, then you would see the ships that did not transmit their VMS, but they are in the fishing ground. The fishing ground of Indonesia, as it can be seen from the image, is of course the North Natuna Sea, the sea between Celebes and Philippines, and the sea on the south part of Papua. And in 2017, the operation has caught a lot of illegal fishing, and the practice has to be continued to protect Indonesian water. So in 2020, we have a research group here under the leadership of Dr. Ahmad Arif, the director for remote sensing research in Indonesia, that to develop again using ingenious technology, the ship detection system using synthetic aperture radar. In this context, the data was using Sentinel-1. For example, this the combination of Sentinel-1 data from March and August 2020. So using Sentinel, the research team could plot the ships that were here is sailing between Batam Island and Singapore and Malaya Strait. And of course, what we wish to produce the operational surveillance system is more satellite data. And if there is one, then we could build an application together with the Ministry of Maritime Affairs and Fisheries and Indonesian Coast Guard. The data also from Sentinel is used by the research group is to detect oil spill. Here again, the area of interest is between Indonesian and Singaporean border. This application is the research was to develop an application together with Ministry of Forestry and Environment, which is the Indonesian authorities that who has the will conduct the law enforcement for the maritime pollution. The image from Sentinel that was taken by the research group was between Batam and Bintan's Island in January and June 2021. And using their algorithms, they could detect the the uh, the oil spill here in the case of the picture on the left side. And during series of data of every month, they could compile statistics on the number of oil spill location in Indonesia and oil spill spread area in Indonesia between January and June 2021. Here you can see that the more spillage is happening in March, which is among others due to the current season. so the ships is spilling the oil during the season when the current is entering Indonesian water. Among other, the research on this area is done by Mr. Afghatani using the Sentinel-1, but for the different sites, not between Indonesia and Singapore, but in Karawang in the West Java. Another notable research using synthetic aperture radar data is on the use for the application of paddy growth monitoring. This application, the one that we has developed together with Ministry of Agriculture, is called Syscrop 2.0. Every 2 weeks, this application, of course, it's a combined optical and radar data, producing the map of paddy field in Indonesia with its growth status. Here we have a status of almost harvest and after harvest and so on, and land preparation and so on. This data is very crucial to be used for the national food productivity, and that will have to be collected by the Indonesian Statistic Bureau and the Indonesian National Development Planning agencies to formulate the policy for food sustainability in Indonesia. Among other, the current research on this topic was done by Professor Sudiana from Universitas Indonesia, along with, of course, the others author was from Research Center for Remote Sensing of BRIN about the method for paddy growth phase modeling using Sentinel-1. future research that we foresee we will have to perform is to develop methods for carbon accounting using synthetic aperture radar data. The image shown here is from the website of Ministry of Environment and Forestry. This application called Simontana. It is for the forest inventory, a nationwide forest inventory, and currently developed with, of course, optical and SAR data, where they classify the different kind of forests, mangrove, the swamp, and then forests that were used for industrial or agro industry, and other kind of forests. Synthetic aperture radar data also used in Indonesia by the research of Professor Sudiana again and his team, including Dr. Ahmad Arif and Mr. Ahmadullah, to calculate the burn area from the forest fire. On the left top is the application that was developed together with the Ministry of Environment and Forestry on the monitoring of hotspot of the forest fire, and this picture was taken on Friday, just last Friday, and the research, among others, done by Professor Sudiana is to classify the damage area or burn area from the forest fire here using neural network, and another is to make a quick mapping using SAR data by Mr. Rahmatullah. Another notable research done in Indonesia is using synthetic aperture radar data for the land subsidence. Using SAR data to estimate the land subsidence. In this case here is a study done by Dr. Widodo. He has done the land subsidence study using Terasar X in Jakarta. And also there is another study by Dr. Rianto from Universitas Indonesia. Dr. Widodo is from Center for Remote Sensing of Brain. Dr. Rianto performed studies on the estimation of urban flood potential in Jakarta, and here is this also validated by the real data from the municipal government on the cases of flood. Can these two knowledge is among others that will be used to contribute on the project by from the Ministry of Public Works, that is a flood management plan. The ministry is currently proposing that it will develop infrastructure for flood management in two watershed, which is in West Java, in West Java, in Cirebon, near Cirebon city. It's called Cimanuk Cisanggarung watersheds. Those are the name of the two rivers. And also in Central Java, near the city of Rembang, it's called Jratun Seluna watershed, which is the acronym of the name of four rivers that runs through that area. And as you can see, the pictures on the bottom was the current images from the high tide flood that happened in Semarang city of West Java, which is in the Jatun Seluna watershed. And Another application, research and application of synthetic aperture radar is, of course, on the digital elevation model. And these studies, among others, is done by Dr. Rahmat Arif, who developed a methodology for estimating the digital elevation model using SAR, in the case of TerraSAR X. And this can be applied, can be used. We have today Professor Arif from Geospatial Information Agency, which is the mapping authorities of Indonesia. Those are the website of the institute that, among other, provided the nationwide digital elevation model. So we are hoping that we could, in the future, contribute on the DEM generation for the nation, for the mapping agencies. And of course, in BRIN, we also have a Center for Satellite Technology. I suppose here also present Dr. Wahyudi Hasbi, the director of the center, which we develop satellites, microsatellites at the moment. This is our capacity, and develop and operates, of course. And back in 2017, 2018, we collaborate with Chiba University, with the laboratory for Professor Josapat, to design together a synthetic aperture radar microsatellite. So our task in BRIN is to develop the satellite bus, because that is what we are have experience for. And from Chiba University, they developed the SAR payload. In 2018, they have finished the engineering model of the synthetic aperture radar payload with a deployable antenna. And knowing that synthetic aperture radar has so much potential for Indonesia to different kinds of application, important application in Indonesia, BRIN is currently proposing a constellation of synthetic aperture radar in near equatorial orbit. You can see the the green line over there. The green orbit is the two synthetic aperture radar in the orbit of 10-degree inclination on that case. And we simulate that these two SAR will be able to perform daily observation, daily repeat in Indonesia. So it will be very useful, for example, for the case of illegal fishing and the oil spill monitoring, because with the current SAR system, which mostly in polar orbit, they revisit Indonesia every month. And so we wish to develop this satellite for the use of equatorial belt country like Indonesia, and in Africa, and of course in South America. So with the oil spill, even the requirement is several times a day. Ladies and gentlemen, this is, of course, we are hoping that in the future contribute on the DEM and really that has so much
for Indonesia, different types of application, important application in Indonesia. Green is currently focused constellation of radar in the near equatorial orbit. You can see the the green line over there. The green orbit is the two synthetic aperture radar in the orbit of 10-degree inclination on that case. And we simulate that these two SAR will be able to perform daily observation, daily repeat in Indonesia. So it will be very useful, for example, for the case of illegal fishing and the oil spill monitoring, because with the current SAR system, which mostly in polar orbit, they revisit Indonesia every month. And so we wish to develop this satellite for the use of equatorial belt country like Indonesia and in Africa and of course in South America. So with the oil spill, even the requirement is several times a day, but this is the best concept that we have right now. And we are trying to develop indigenous capacity in developing synthetic aperture radar subsystem as well. This group was performed by Dr. Bambang Setiadi and Dr. Faro Aji, among other. They have built lab scale synthetic aperture radar system showing on the image on the left, and those two horn antenna was on board of auto vehicle, and the auto vehicle is moving, and of course it has some calibration surfaces, and it is making an exercise of having a synthetic aperture radar images. And those are the achievement until this year, 2023, which they have developed the RF system, the antenna, there are phase array antenna as well. They're trying to develop data handling and data processing system and calibration, of course. And next year, they will continue do this apparatus that they use in auto vehicle. They try to minimize it, and we hope that we could make the airborne system for the testing until 2-kilometer range. The one on the ground is only 150 and 300-meter range. And also they wish to be able to develop the full polarimetric and circular polarimetry SAR. So this hardware that the miniaturization that we develop is we hope to be flown, among others, by BRIN aircraft. Currently, BRIN has two flying laboratories. One is a Piper, and another is a STEME, light surveillance aircraft, that can be fitted with synthetic aperture radar for airborne tests. And what would happen after we can make an airborne test? We hope that we could further minimize it and make the component to be space qualified. We put it in a vacuum and we test it with the anechoic chambers so that later we would be able to put them in orbit in microsatellite. So those are the activities that we have in BRIN. And what do we need from this community is we need very much collaborators. We do not have enough manpower, capacity, funding to develop this dream project. We need collaborators from this community, and as a research collaborator, as an investor. So
Also, we need to benchmark and validate our research and concepts. So we need visiting professors. BRIN will accommodate, has a accommodation scheme for visiting professors where we would pay for the local accommodation, but the researchers, the professor, the scholars will have to come to pay for the airfare to come to Indonesia. We also need postdoctoral students. So if any of you just finished a doctoral degree or any of the professor here has a PhD student, please promote our research center in BRIN that we need a postdoctoral student for various topics, including SAR, to work together with us in developing high quality research. And other than that, for the university professor from Indonesia, we need research assistant, which means a graduate student who wish to be able to that could work in our laboratories with our researchers as a research assistant, and their tuition will be paid by BRIN in the scheme of degree by research. So they are in our laboratories performing research, have advisors in the university. Of course, we will together become the academic advisor of the candidates, and the tuition will be paid by BRIN. And I think that's about it. My presentation today. On behalf of BRIN, I would like to thank all of you, and please enjoy Bali. Thank you very much. Good afternoon.
Thank you. Thank you, Dr. Heru. So I think many application of synthetic radar have been explained by Dr. Heru, and of course, we hope in the future we can follow up to create collaborative cooperation with you, all of you here attending this conference. Okay, thank you, ladies and gentlemen. The next speaker is Dr. Upendra Nath Singh. Very interesting here. We are proud here with Dr. Upendra because, Dr. Upendra face younger than he is. Okay, so anyway, Dr. Upendra graduated from Indian University. He has 2 master degree, bachelor engineering and PhD DEA from French University, and I believe he has 100 awards, maybe 100 awards. But here, I just want to deliver. He got 2 highest medal from NASA. NASA Outstanding Leadership Medal. This is the highest medal in NASA. So I believe that Dr. Upendra has extraordinary experience, and also he will show us the movie. I heard from Dr. Ilham that the movie cost is about 1.5 million US dollars. It's true, Dr. Upendra? Apa nih? So, I invite Dr. Upendra Nath Singh to deliver presentation. First is in PPT, and then the movie. Please welcome Dr. Upendra Nath Singh. Remote mic.
So, if, yeah, you have a slider, so if you can use it so that that will be helpful. For the slides. Yeah. Thank you. So, first, I would like to thank Josephette to invite me here. And I was attending the IGARS in Pasadena. And I'm a working group lead for the active optical. And so one of our deputy, like the co-lead from the Instrument and Future Technologies, she approached me, Delvin from New Zealand, and she approached me and she asked me that there is a Apsar is going to be happening in Indonesia. And we would really like you to be there and represent and talk about something different. As you all know, you are a radar expert and you have worked, in this area for a long time. So why in the Apsar, I'm going to talk about something very different. One of my motivation was that LiDAR and radar, they are completely analogous. I'm your little brother in a sense that you guys have a frequency, you have the larger wavelength, and I have a higher frequency. You have a lower frequency, larger wavelength. I have a higher frequency, smaller wavelength. So the things which you cannot see, I can provide you help with. And that's where the LiDAR comes. Okay, so I will talk about this thing a little bit more. They are both complementary technologies. One looks at the large object and one looks at the very fine, very finite, very infinite molecules, dust, aerosols, which is not able to detect by radar. So they are very complementary. So what I'm going to talk today is I will start with my active optical remote sensing, but moreover, in the beginnings part, I will talk about NASA Earth Science observation programs, that how NASA is using all the active and the passive remote sensing instrument in conjunction and in formation for understanding the Earth atmosphere. So that's my first part. And then in between, I will, because we see a lot of students here, a lot of people, young people, and then I will introduce the concept of LiDAR. We will talk about different technique that LiDAR uses in a very fundamental way. I can assure you that there's no equation in my whole talk, okay? So I kept it at a very, very fundamental level. And so it's not a talk, it's a dialogue with you, So first thing is that, is it working? It does not advance. You have the clicker? Okay, now it's good. Okay. Okay. Oh, now it works. So these are the national objective of NASA. Basically, some of the key part, and this is not Earth sciences, but these are the real goal of NASA, that what we are doing, So implement a sustained and affordable human and robotic program to explore the solar system and beyond. Extend human presence across the solar system, starting with the moon by the year 2020. And now you are seeing that we have started going for the Artemis program, where we will put the first woman and first African-American of the color, person of color on the moon. Then the part which I am very much interested in, develop innovative technology, knowledge, and infrastructure, both to explore and support decision about destination of human exploration. NASA, literally, if you think about it, NASA is a sensing agency. We sense. Everything in the NASA is sensing and exploration. And for sensing, you have to have sensors, active and passive. So when we are here on Earth, we sense the Earth atmosphere. When we are in the Mars, we sense the Mars atmosphere or Mars, any kind of minerals or anything. And then the same thing with the moon. So instrument becomes a key part of the technology and key part of the things for NASA. So the fourth part is that we promote international and commercial participation in exploration. NASA has collaboration with a lot of countries. Most of the space-based countries, NASA goes ahead, engages them, works with them, and develop the partnership, because we at NASA, we believe in diversity. The diversity of culture and diversity of thought. We have partnership with Japan, we have partnership with Europe, we have partnership with India, we have partnership with Indonesia, we have partnership with every country who is engaged in technology area. And we nurture those kind of participation, and we benefit to having we have a lot of program with Japan, and we lot of program with ESA, and we benefit because bringing a diverse kind of mind and the scientists and the researchers, the industry, academia, all those people are engaged. NASA is very open, you know. The last part is that where I will be focusing on is study the Earth system from space and develop new space-based and related capabilities for this. That's where my life, for last 30, 40 years, I have been at NASA for 30 years, and then in France, I have devoted my life pursuing those technology and the techniques that could help for us, for NASA to understand the atmosphere, Earth's atmosphere. These are the one of the things that how we do this. The overarching goal is to advance our science system science through space-borne data acquisition and research analysis and predictive modeling. Literally, it's just not taking the data, but how you analyze the data, how we interpret the data, and what are the predictive modeling. So this is not a one aspect. We tie those measurement to the models, you know, okay? So 6 major activities which we have in this thing: building and operating Earth observing satellite mission, and I will talk about it. I will show you some of the missions. Many with international and intelligence partners. We very much value the international intelligence partners. When I say interagencies, that means NOAA and other agencies in the country, making high quality data products available to the community. NASA data is completely open because we are funded by the taxpayer. So by law, any data which we are collecting, we share with people, with the international community. We don't keep it to ourselves that, no, this is secret, we cannot give you. No. Conducting and sponsoring cutting edge research. Then we have applied sciences, and this is where developing technology to improve Earth observation capability. And then we have a lot of emphasis on education and public outreach. Everything which we do, we try to engage the young minds, the people, the next generation of the people, that how they can help us. And then everything that which we do, we publicly, we announce it, we put the data together, we tie those data and observation to the societal benefit. Science has to serve the mankind. We are here to serve how can we make the life better on this planet. So that's the key goal of NASA, that how NASA can work with the international partners, interagencies, and bring something that can help common people, that can make their life better. And that's the goal of NASA. So we have a lot of these are the satellites that which are in, a lot of them are in orbit right now. Calypso is the laser instrument which just got decommissioned. When we launched Calypso, the lifetime of Calypso, this is a, and I will talk about it, it's a LiDAR-based instrument, and studying the profiling of the cloud and aerosol. So when we launched Calypso, the lifetime of the Calypso was supposed to be 3 years. Guess what? It's been 14 years. Continuously, it has worked. It's one of the, miracle. Something like 500, 600 papers, 1,000 papers has been published by the people in Japan, China, all over the Asia Pacific, Europe. It provided so much support, and it just got decommissioned. I think it was last month that finally we said that, hey, this guy has worked very, very hard. Let him retire. We fly with the CloudSat in the formation. We have a GRACE mission. We have a source. So we have a lot. Landsat. This is again USGS mission. We have Aqua, Terra, Aura. So all these instruments are, each one of them, this is a NOAA instrument, but most of the instrument that which you are seeing, even with the interagencies, we develop the technology, we develop the part of the instrument, and we provide and work with different agencies to deploy it. Here you can see that there are operating mission, and these missions are with the international. For example, Calypso, so all those highlighted part that which you are seeing, they are all with the international partner, which is not purely by the NASA. Calypso was partners with the French CNES, Centre National d'Études Spatiales. CloudSat is also with Canada. So all these instruments, if you can see, majority of the instrument NASA is working if they are with the international partners. So we are very open, and we work with them quite close. The TRIM, I think it is with the Japan, JAXA. So we are working with JAXA, and it's a long mission. So here is a future timeline. Some of the things I will go ahead and I'll put it together. These are the GRACE, Destiny, and different PACE missions, SWAT mission. I don't have time to go together, but this is the kind of timelines which we are talking about. And then the key part which is coming here, that NASA has recently got into the venture instruments, that they are building this instrument in the beginning and slowly maturing them. They have a small sat missions. So all these instruments that which we are in the venture, and they are basically maturing, and they will be ready to be launched in succession. So now, coming back to the LiDAR. What is LiDAR? LiDAR is a light detection and ranging, just like a radar, radio detection and ranging. The difference is only that in radar, you have radio waves. In LiDAR, you have light waves. The rest of the things are same, okay? It is an analogous instrument, and the key part of LiDAR, why it is different from the radar in some sense, is that it can provide a very high resolution measurement. It can provide a vertical profiling, which is a key. Because if you want to understand the transfer, if you want to understand that how it is varying over the altitude, LiDAR provides like a pencil beam and provides a swath of the vertical profiling, which is a unique capability. And that's where it complements the other instrument, the passive remote sensing instrument, which gives you a swath. So you have a swath. And then in between, you have this fine vertical profiling. It tells you that how it is varying, and that's the key part which no instrument can provide. And that's where active optical remote sensing is very, very powerful. So what do we have in LiDAR? 3 parts, 3 or 4 parts. One is that you have a transmitter, just like a radar. You have a source. So you send the light, and then you have a telescope, basically. So you have a telescope, and I'm going to bring them because it's crazy here. So what happens that from the laser, you send the laser beam. You can see here the laser beam comes over here and it gets transmitted. And what we transmit is just right. It's a called coaxial. There's a biaxial also that we can put a mirror in parallel and come into the same area. So you put a coaxial, this is the simplest one, and the light comes and goes in the atmosphere. Since it's a monochromatic coherent light, monochromatic light, it interacts with the molecules. It gets reflected. So think about when radar looks at a plane, what does it do? It hits the plane and you have an antenna that you look at the return. So just like for the radio waves, a plane looks a big object. Guess what? To the LiDAR, it does look like a plane. Okay, it's because of the frequency and wavelength is so small. So even a small particle, it reflects. And then when you bring them up, sorry. Yeah. So then all the return photons which are coming back from the atmosphere, they get collected by the telescope, they are processed, and then you have a spectral selection that you can choose the wavelength, you have a photomultiplier tube. So then you have, these are the three parts, laser, telescope. So once these photons are coming back, you do the spectral selection, and then you detect with optically with the photomultiplier tube, and then you can look at it, the time variation of the return. This is simple. This is simplest thing, and that's why I got into it, because I don't understand the complex things. So for me, it was a very easy area to get in, and very fascinating technology. One of the things I was given a challenge by NASA, because NASA was looking for that how we can make the multiple measurement using not tens of lasers. How can you have one or two lasers that you can make these measurements, and how they can be successful in a space? So this particular chart, I will walk you through. When I showed this chart to NASA administrator, Dan Golden, he looked at this chart and said that, Upendra, it was in 2001 I created this chart. He said that if there was an Olympic of the chart, this chart will win the gold medal. So I put a lot of thoughts, and I was awarded $80 million program by NASA administrator directly to develop the program as a PI, and I ran this program for 10 years with NASA Langley and NASA Goddard. So let me walk you through, it's very interesting. So if you look at it here in blue coded, the 6 priority measurement. So in the blue, if you look at it, CO2, wind, surface mapping, aerosol and cloud, ozone. So there were 6 primary measurement which NASA wanted to do using the active optical, where they needed profiling, wind profile, aerosol profile, cloud profile, CO2 profile. So all these things they were looking for, a surface mapping, like ISAT kind of instrument. So what I told them that, look, we can use the 6 priority measurement. So that is our goal. I hypothesized that I can use only 4 techniques, LiDAR technique, 4 LiDAR technique to make the 6 measurement. And I will talk about those techniques. Those techniques was Doppler LiDAR, laser altimetry, dial, and backscatter LiDAR. And I will talk about these things later on. So I can use, for 6 measurement, I can use 4 technique, and I need only 2 lasers, 1 micron and 2 micron. YAG 1.064, 2 micron, 2.05 micron. So I told the administrator that, look, I need only 2 lasers to make everything that which you want me to do. And these 2 lasers are not different. Lasers are almost the same. What creates the problem for laser to be in space, just like Calypso, there we had a lot of failure of lasers in space before Calypso, and ISAT 2. Even ISAT 1 had a lot of problems. These are the common factor: laser diode, laser-induced damage, frequency control, and electrical efficiency. So these are the key technologies that you must address for 1 micron and 2 micron. So the program I formulated is not building the laser we already had, that how we are going to mitigate those key technologies that we can improve those things, and that will be extend the life of laser in space. Calypso was the first system that which followed the path, and it was very, very successful. So here is the for all the students and everybody, this is the slide I really I like to talk about. So the simplest technique of LiDAR is called it's called the backscatter LiDAR. You see that here? So what happens? This is an intensity level measurement. You send a beam of light, you transmit a beam of light, and you look at the return. This is the density, and this is the range. So you send a light, and you look at the return. And what you measure is the time and intensity. And that gives you ranging, and it gives you the density. So that is the simplest, like Calypso or other LiDAR. The second measurement, which is here, it's ISAT, mass balance, vegetation canopy, and land topography. There, you are just measuring the range. So you send a laser light over here, and you look at the return, and you look at the time of arrival, and that will give you a range, that what is the range of the, of that particular ice particle or the land topography. The third one is a little bit complicated. It's called differential absorption LiDAR. There, you send 2 different wavelengths. One, which is absorbed by the constituents, for example, CO2 or ozone. Okay, just like you know that certain kind of spectroscopy, certain wavelengths are absorbed and certain wavelengths are not absorbed. So we send 2 wavelengths which are very, very near, of the order of picometer. Okay, and you look at the return. So what happens that here you are transmitting 2 green pulses here. Now, the one which is called lambda off, it does not get absorbed by the constituents. Okay, so that becomes your reference wavelength, that it's seeing the same aerosol, same cloud, everything. But guess what? The second one, which is absorbed, is smaller, because while it goes in that path and comes back, it is absorbed by that one. So if you take the ratio of lambda on and intensity of lambda on and lambda off, directly you can measure the concentration of that particular species. And the white cell and other things that which you do, that you send a light and look at the light back. So this is called differential absorption LiDAR. And there you are measuring ozone or carbon dioxide profile. And the last one is a Doppler technique. Doppler technique this is a frequency-based measurement. So you are sending a frequency over there, and you are looking at Doppler shifted frequency, and that gives you the velocity. So these 4, so density, range, and then concentration and velocity. These are the 4 primary or 5 primary measurements you are using the laser, and just varying that how you are detecting. So the detection is different, transmission is same, collection is same, detection technique is different. So that's the part I wanted to get to you, that this is the basic principle of LiDAR, and it's very simple, depending on what you want to achieve. There are different constituents. This is the key measurement of earth sciences. And this area that you can see, weather, climate variability, atmospheric composition, earth surface interior, water energy cycle, and carbon cycle. These are the 6-7 area of measurement that NASA is always interested, and anybody who is doing the earth observation, they are interested. So given this particular range of the measurement, what technique is best to measure what? It's not that LiDAR can measure everything. Their radar is like a passive instrument. So we have to optimize. LiDAR is not a solution for everything. So here's my optimization. You can use the Doppler LiDAR, and guess what? You can measure the tropospheric wind. So if you are using the technique, that part, then laser altimetry, that will give you measurement of this key parameters: land surface topography, surface deformation, sea ice thickness, ice topography. That's the laser altimetry technique. And then the biomass, just like Japan has this MOLI system is coming up. We have the JEDI, which is right now working in the space right now, measuring the vegetation canopy and biomass. Then the third technique, ISAT, was also an ice topographic measurement. Third technique is dial. Dial will give you atmospheric water vapor, ozone vertical profiling, and surface gas concentration. And the last one is backscatter. So backscatter gives you cloud profile properties, aerosol properties. So by using these four active optical measurement techniques and technology, you can really map all the needs of NASA. And that's what I had proposed, and it was accepted, and we went through that. So this is the NASA's Earth Science Decadal Survey measurements that they had a 3-phase of measurement. So these are the measurement they wanted to do in first phase, tier 1, tier 2, and tier 3. And I'm going to tell you that this part, lasers was chosen to make this 1, 2, 3, 4, 5, 6 measurement. So there were 6 missions which were focused on the laser and LiDAR. The second was, this is the radars. So again, you can see that. So these missions, IMAP, SWAT, and ACE, and all these things was the radar part. The third part was passive optics. Passive optics will cover these measurements. And finally, we had this passive microwave. So you can see a pretty good coverage of active and passive laser and radar, how NASA can map or can do all the Earth science measurement just by using like collaborative or an ancillary technology, laser and radar. So radar and LiDAR, they are not separate. They are kind of together. They are helping together, going together. These are the instrument that I talked about it, that different lasers, that what wavelength they have for the ISAT, for ascent, for the wavelength, wind here, and then the LiDAR satellite to satellite interferometer, mapping laser altimetry system. So now one of the area that which we looked at the column CO2, these are the airborne instrument that NASA has built, and they measure the CO2 from an airborne platform. Then this is the ascent missions to going in the space, and then finally finally this mission, ascent mission, is yeah. So that was the ascent mission for the CO2 measurement. Now towards the 3D mission, towards the wind, we have a different kind of technique. All those techniques was done like dawn and twilight to measure the wind from a airborne platform. Then it was matured, compared with a ground-based instrument, and then there is a missions for this is the mission, 3D wind mission. Right now we're preparing for the 3D wind mission, and basically we are also going to work with JAXA. Aeolus was launched by Europeans, but NASA is right now working with JAXA to see that how we can do the coherent Doppler LiDAR measurement for the wind. And so this part I will take, this is from my colleague, Calypso instrument. I'll give you some idea that what the imagery looks like and what it provides. This was again launched in 2004, Calypso system, and just now it got decommissioned. So this has a polarization LiDAR, Calliope. It has an imaging IR radiometer, and then it has a basically wide field camera. So there are 3 different instruments are lining up here to understand and to profile the cloud and aerosol. I don't have time to detail, but this is you can see that this is a 1 meter telescope. They have a YAG laser, which is 110 millijoule. So this whole thing was put together at NASA Goddard Space Flight Center, Langley Space Flight Center. I was very much involved in early part of my career. And this is basically 8 train. So Calypso, CloudSat, Aqua, OCO, the Orbiting Carbon Observatory, Parasol. So all these auras. So you can think about, they call it 8 train. All these instruments are mapping the Earth atmosphere after, like, see that 1.38, 1.33, 1.3. So this is the seconds and minutes that they are following like a train. And each one is sampling the same kind of atmosphere. So this is the Calypso. You can see that they are 2 minutes behind. And so all the instruments are orbiting the Earth in a formation. Now, so this is the kind of product, if you really look at it, this is the kind of product that you can get. Total attenuated backscatter, and you can see here 10 to 12 kilometers. We are seeing a lot of ice clouds here. This is also in a different kind of imagery that which you are seeing. And for example, this is the aerosol and cloud observation, and you can see India is here. And so how does it look like? So this is the MODIS. This is a passive remote sensing instrument. It provides you a swath, the passive remote sensing. And that's when here comes the Calypso. If you look at the Calypso, the same swath, it is providing a vertical profiling. This is the altitude. So you are seeing altitude profiling over here. So it's a kind of a small cut, you know, one particular dimension, and then the vertical profiling you are seeing with the clouds and aerosol. The similar kind of technique ISAT used to map the ice, ice at using the laser altimetry. And so all these techniques are leading to the disaster management for the countries that were looking at the data assimilation and hazard part. And this is the part where the people or the countries can combine together and look at the disaster management. So conclusion, over the past decade, many key NASA Earth Science measurements have been supported by Earth Science Technology Office investment. I was one of the beneficiaries to that. Active optical remote sensing making significant contribution to NASA Earth Science program through surface, aircraft, and space-based observation. Active optical remote sensing can be expected to play an increasing role in the future as we advance into the decadal survey era and benefit from the investment in the LiDAR technologies. So this is my presentation, but I'm going to show you a video that combines everything I have talked about. That what is the plan of NASA and how these instruments are mapping the atmosphere of Earth. So I will stop by and just hold the question right now. Just watch the movie, and it talks about the vision of NASA's vision of combining the active and passive sensing, how to look at beyond 20, 30 years, how to work with the international partners. So if you guys can turn the light off, turn the movie on, and just sit there, relax, and watch. Show is on.
NASA has studied our home planet for more than 40 years, from space, in the air, and on the ground. The next 20 years will see a revolution in Earth science. Emerging technologies will enable new measurements to reveal the complex interactions among Earth's natural systems. Observations will be more efficient and models improved for forecasting weather, climate, and natural hazards. This knowledge will help us better understand and predict hurricanes, earthquakes, and climate change. It will lead to practical applications to improve the quality of our lives. Today, NASA flies multiple spacecraft around Earth. In the future, we will have many more distributed observations. Underwater capabilities will look at ocean circulation, currents, temperatures and salinity. UAVs, or uninhabited aerial vehicles, will validate and augment the data captured in space. New LiDAR instruments will measure 3D winds, cloud heights and ocean turbulence, as well as vegetation and canopy heights. Space-based radar will be able to monitor changes in stress on major earthquake faults, as well as soil moisture and cloud dynamics. And other systems, such as radiometers and spectrometers, will provide global measurements of Earth's atmosphere, land, and oceans with unprecedented resolution. Hundreds of small satellites flying in formation or maneuvering with respect to each other will track time-critical events. They could simulate a large aperture for very high-resolution measurements without a large satellite. Using high-resolution ensemble models will enable us to better predict the severity of storms and the best and worst-case scenarios. We'll be able to predict how much rain will fall and when, 7 to 14 days before it actually happens. And we'll be able to observe and even predict earthquakes, volcanic eruptions, and tsunamis. Formation-flying satellites will have the ability to reconfigure on the fly to watch these events evolve. Constellations of complementary satellites with different capabilities will work together autonomously. That means if one satellite fails, another will be able to replace or repair it. Multiple spacecraft will provide an internet in space to exchange information, to command one another, and download data to users and decision supporters in a timely manner. Different vantage points will provide vertically and horizontally resolved measurements. High-resolution optical and infrared sensors on satellites will be placed in stable orbits at the Lagrange points. This will allow measurements of variables like clouds, water vapor, ozone, and aerosols under constant sunlit conditions over broad geographic areas. All this additional data will require large-scale exascale computers to solve billions of operations per second. These computers, coupled with various types of models, will allow us to visualize and understand the interactions among Earth's systems. Complementary and comparative measurements will provide global, regional, and local scale data products. NASA won't do all this work alone. Many missions are international partnerships between multiple nations. And when the data are shared and compiled among the international community, it will allow us to better understand, predict, track, monitor, respond, and plan. This is our vision for the future, a vision that harnesses technology to create knowledge and to improve the quality of our lives.
To acknowledge that can you hear me now? So I just want to acknowledge a lot of people worked on this kind of video, and a lot of data was brought in, and we wanted to make it a meaningful. This is not to show you the imagery, but to show you the vision that how it can help the mankind. It's not about, yes, we have all this technology. What is the technology? What is the means? What does it mean to the people? What does it mean to the common people? So the theme of this technology is that we have this technology and how it can lead to societal benefits for a common man, whether it's a hazard, whether it's a hurricane, whether it's a tsunami, whether it's a volcano, and whether understanding that weather forecasting for 7 days, 10 days, 14 days, each and every human being will be affected and can benefit from these things. So on behalf of NASA, I want to thank you for your time. And I'm thankful to NASA and my colleague here who gave me the opportunity to come over here and interact with you. And I continue to look forward to. I'm thankful to Josephat, and I'm thankful to my friend Lam that who provided me a lot of support and a lot of help in coming over here, you know, that how to come from the airport to here, it was very difficult. So thank you, Lam. Okay. So any question?
Thank you.
I'm open to question. If you have any kind of fundamental question, I can answer. Yes, sir. I can I don't need a mic.
Thank you so much, especially the LiDAR Doppler part and the differential LiDAR part. It's new to me. I mean, of course, I understood from a radar sense,
yeah,
but it was fantastic way to measure things, right? It's fantastic. I couldn't pick. But
Thank
one question I have on the technical side is because given so small wavelength, high frequency, if you deploy such thing in space, like LiDAR, yeah, so for things like topographic measurement, like vegetation, height and stuff, you need to have sufficient density of points to make meaningful measurement. Yeah. So do you think that would be enough energy going back to the sensors?
Yes.
A little bit more.
We are.
Atmospheric interactions, noise.
No problem.
No?
ISAT did the same thing for 6. ISAT 1, ISAT 2. And right now we have an instrument called JEDI, which is making measurement from the space station. So it all depends that what's the technique is. Calypso measured for 13 years. So if they are making aerosol and cloud measurement, they are just because the detectors are so powerful nowadays that you don't need too much of energy. Okay. Most of these wavelengths are not absorbed by the atmosphere. Okay. They are reflecting that atmosphere. If you are using a dial technique where certain kind of like CO2 and ozone, when we are measuring, you need certain kind of, even wind to go through the troposphere. So you need certain kind of energy, and that's why pulse energy is important. So if you're doing a differential absorption LiDAR, you need a pulse LiDAR. But a lot of like CO2, when you're making a CO2 measurement, you don't need a pulse LiDAR. You can do with the CW, like a spectroscopy. So each and every instrument or measurement, we look at it, that what is the return, what is the absorption and other things. Everything is calculated. And based on that, you size the instrument. Because as you know, when you are going in a space, the power becomes the most important part. So you have to have a swap, the size, weight, mass, and the power. These parts we optimize in NASA. So it takes a long time. The program I started in 2000, JEDI laser, which is flying right now, it came out of that program. And it got launched. It took about 20 years. So space, especially LiDAR, let me tell you, it's very expensive. But once you do it, once you know what you are doing, you have Calypso kind of instrument. There's no instrument can give you 13-year performance and high vertical resolution of looking at the ash, looking at the dust, looking at the particle. So the dividend or the payoff is quite large, but the technology is very cheap. Not every country can do those things. So that's why we go and work with, right now I'm looking at the wind program. I'm working with the JAXA, I'm working with ISRO. ISRO can provide because NASA cost to launch and put the bus together is enormous. So we go to India and say that, hey, you have the launch capability, you have the bus and everything, can you give us this? And we collaborate. Same thing with the ESA, same thing with the JAXA. Because between the two space agencies, you cannot give money to anybody. If JAXA is going to partner for a certain part, JAXA will put for their contribution, their part. Similarly, ESA, similarly ISRO, they come at no cost. Okay, like NISA, right now NISA is with the ISRO. Okay, ISRO is doing a lot of things, and JPL, NASA is working together, but a lot of expense is being borne by the ISRO, and some of the expense, there's no exchange of funds between these. Does that answer your question?
It perfectly answers. Thank you so much, Dr. Pendra.
Thank you, Dr. Pendra. So I have an experience in producing a topographic map by using LiDAR drone. We map an area about 100 hectares. By terrestrial methods, we need 2-3 months to produce topographic map. But by using the LiDAR technology, we just need only 3 to 4 days to produce topographic map. The result is great and reliable. So that's why LiDAR technology is very important in the future. Again, please give a big applause to Dr. Upendra. Ladies and gentlemen, it's getting colder, correct? So please stand up. Please stand up. Move your body, move your body. Okay, follow me. So we just move our fingers like this. Okay. 1, 2, 3, 4. P, L, C, X. P, L, C, X. Okay? Understand? 1, 2, 3, 4. P, L, C, X. P, L, C, X. P, L, C, X. Enough. Thank you. Okay, ladies and gentlemen, we are going to the church keynote speakers. Please, Dr. Michelle Angelo, before you present your presentation, I would like to deliver your CV in brief. Dr. Michelle Angelo, of course, younger than me. Correct? You are younger than me. Okay. He got BSc, MSc, and PhD in IT, Information Technology, Telecommunication, with summa cum laude honors. Please give a big applause to Dr. Michelle Angelo. And now he's a research scientist, head of new space SAR research groups in DLR, Germany. There are many awards you received. One of them is you already received the DLR Science Award in 2016. And the last one is the Best Paper Award, the German Microwave Conference in 2019. Please welcome Dr. Michelle Angelo. Time is yours.
Thank you, Professor Putut, for your introduction. Thank you, Yosafat. Thank you for your invitation. And okay, thank you again. And good afternoon, everyone. So today, I'd like to talk about TandemX. I'd like to share some recent updates about the TandemX mission. And I will then move on to the more general topic of multi-static synthetic aperture radar to discuss how such systems might look like in the future. TandemX has marked a milestone in the history of synthetic aperture radar. So here you see two SAR satellites. The first one is TerraSAR-X, was launched in orbit of 514 kilometers in June 2007. The second one, nearly identical to the first one, is TandemX, was launched 3 years later in June 2010. So both satellites are fully functional after over 16 and 13 years of operation. And now the X of TerraSAR-X and TandemX stands for the X band of the radars on board satellite, which are characterized by a center frequency of 9.65 gigahertz. And TandemX is not only the name of the of one of the two satellites, but also the name of the overall missions and
peculiarity of the Tandem-X mission is that the two satellites, as you see in this animation, are flown in a close formation. So they are only few hundreds of meters apart. And in particular, you see one of the two satellites is forming an helix around the other satellite as they are moving along their orbit. And in this helix formation, the horizontal separation between the satellites is obtained through different right ascension of the ascending node of the orbit of the two satellites, and the vertical separation is obtained through slightly different eccentricity vectors of the orbit. So what happens here is that the relative motion of the two satellites is obtained by setting the orbit parameters of each of the two satellites, and therefore this formation is safe without the need of autonomous control. So the two satellites will always be at least 120 meters. This helix formation allows producing a very accurate digital elevation model. So three-dimensional model of the Earth's surface, like the one you see on the right, at a global scale using synthetic aperture radar interferometry. So the two SAR images acquired by the two satellites have nearly identical amplitude, you see, but the difference between the faces of the two complex SAR images contains the information about the height. This is the so-called interferometric phase. And in particular, in Tandem-X, what happens is that the simultaneous acquisition of the two SAR images avoids the so-called temporal decorrelation, and therefore makes the accuracy of the this interferometric phase much better. So this pattern here is less noisy, and the large separation between the two satellites from hundreds of meters results now in a much better accuracy, height accuracy of the digital elevation model for the same phase accuracy. So what happens is that with the large baseline, we have a higher fringe frequency, so we see much more fringes here, and therefore we can see more detail in our digital elevation model. So this is the Tandem-X global digital elevation model. It's global as it covers the full Earth landmass, so 150 million square kilometers, at a posting of 12 meter times 12 meter, and with an absolute height accuracy in terms of 90 percentile of around 1 meter. This was never reached at a global scale. And data to produce this global digital elevation model were acquired between 2011 and 2015, and Tandem-X global DEM was completed in September 2016. And this is why we call it the Tandem-X global digital elevation model 2016. Some of you might know that a few years ago, in 2018, the DLR was making available to the public 90-meter edited version of this global DM. Now, today, I would like to take the occasion of this keynote speech here at the Apsar to make an announcement on behalf of DLR. And the announcement is that in a few weeks, a 30-meter, so edited version of the Tandem-X DM will be made available on this website. Here you also see the QR code. So this edited version will be available just by registering. So you can just register to the website and download it. So there's no need to apply for a proposal. And in this 30-meter edited version with further detail compared to the previous one available, the sea surface has been flattened, and the areas, the few areas where data were missing, for instance, due to high slope terrain and so on, those areas were replaced with data from other sensors. So this TandemX global digital elevation model, or better, a 50-meter multi-loop version of it, was also the starting point to produce a global forest non-forest map, which you see now on the screen. And this global forest non-forest map is a binary map, 0-1, which display on a global scale the forested areas. And this was obtained from the TandemX data, looking at the volume decorrelation, so the component of the coherence loss due to the volume of the specific case of the trees. But why so the generation of the TandemX EM took so long? And if the TandemX global digital elevation model was completed in 2016, what happened to TandemX in the last year, and what will happen next to TandemX? So this is the acquisition plan of the TandemX mission, and you see that after a commissioning phase in 2010, in 2011 and in 2012, we had two global coverage where data were acquired first with a small baseline of around 200 meters, and then with an increased baseline of around 300 meters. Here, the idea is that we can combine the interferograms with different baseline, and this has two advantages. The first one is that we can resolve phase unwrapping error, and the second one is that we can get even better height accuracy. This is how you get to the 1 meter. A third year of acquisition in 2013 was dedicated to Antarctica and to some specific area, for instance, where shadow and layover occurred, and there it was needed to acquire the data with some specific different viewing geometry. Also, for instance, one example is the desert. On the desert, during the first two acquisition, it was so found out that the signal coming back to the radar was too weak, and therefore it was necessary to produce really a digital elevation model, DM with good performance, to acquire data again with a steeper incident angle. Very important, from 2014 till 2016, there was a TandemX science phase where the scientific potential of the mission could be exploited, and where acquisition with special formations were carried out, and digital elevation model with even higher accuracy were produced. From 2017 to 2020, there was the acquisition of a second global digital elevation model, and together with this second global digital elevation model, it was also produced a change layer, what we call the change DM, where one can really see the difference between the data, so the DM acquired in the period 2010-2014, and the data, the DM acquired in the period 2017-2020. But let me show you some example of this change DM. So here we are in an open pit mine in Hambach, Germany, and you see, imagine like this area is something like 20-25 kilometers times 15 kilometers, and height so spans over an interval of about 1,000 meters. And here you see the the Tandemex BM 2016 over this area, and here the Tandemex 2020 over the same area. So this is just to show you the level of detail of the Tandemex BM, and this is available on a global scale. Now, an open pit mine is probably the best test site to check the DM differences, but let me show you some other examples. For instance, here we are in New Zealand, in the area around Lake Taupo. You see there are some forests. The one on the left is optical, say, image. And here on the right, you see the difference of digital elevation models, so the height difference between 2018 and the Tandemex BM 2016. And what you see in light blue, you see how vegetation is growing. So you see here we have the vegetation. So in light blue, we have the growth of vegetation. And in red, the legend is here, we go up to minus 35 meters, are the area where deforestation occurred. If we move 1 year later, this is 2019 comparison to the DEM 2016, we see that there is a further growth of the vegetation. You see the light blue becomes darker, so the vegetation is growing, but we also notice that further areas have been deforested. So this is also interesting. And let me show you one last example. This is related to the melting of the northern Patagonian ice field in Chile. Here we show the elevation change rate. Maybe here you see. So the elevation change rate in meters per year from the over this region. So we're really talking of meters per year, and areas in dark red here we have something like minus 10 meters per year. So through this difference of digital elevation model, we could measure that in some area we have a elevation change rate of 10 meters per year, and this is really a very clear example of how dramatic climate change is. But it's also an example, a demonstration of how important digital elevation models and differences of digital elevation models are for Earth monitoring. Okay. So after this acquisition of the second global DM, there was a new science phase between 2020 and 2022 with several further scientific acquisition over forests, glaciers and permafrost and urban areas. And as of 2022, Tandemex has entered its 4D phase, where topographic changes of Earth are going to be continuously monitored, and DM change map, like the one you have just seen, will be produced. And now looking at the long-term coverage plan, what will happen is that in the areas where changes are more likely to occur, in the most dynamical areas, you see, for instance, the one in green or in orange here, there will be one acquisition every second year, in Antarctica, in Greenland, even every year. And in the area which are more stable, the one, for instance, here in shaded dashed green, there will be, say, less acquisitions. Okay, so we wish long life to TerraSarex and Tandemex, Now, I would like to move in this last part of my talk to the topic of multistatic synthetic aperture radar. We define radar systems bistatic if the transmitter and the receiver are located on two distinct different platforms. And we say that the system is multistatic if we have receivers, if the signal is simultaneously received on multiple platforms. Now, according to this definition, TandemX is a multistatic system. Although when we really talk of multistatic system, we like to think of really a system which includes several, maybe even chip, maybe even receive only, say, satellites flying in. And we would like to have several satellite flying information because several satellite flying information allows us to collect multiple images with different viewing angle, and this makes even a step further from just knowing whether in a given area of the world there is forest or not forest, or to know how much is the height difference of the tree. If we have many observation available from a different viewing angle, we can retrieve the three-dimensional structure, for instance, of the trees in a forest, as you see here, through synthetic aperture radar tomography. And here you can really see in this example, which was carried out using multiple repeated pass of the Apsar airborne sensor of DLR, you see that in this case, where the acquisition were fully polarimetric, you can also get information about the scattering mechanism. For instance, the blue of the surface scattering, the red of the double bounds, and green the volume scattering of the. We have seen, I hope I could already convince you how important digital elevation models and homograms are to monitor our planet. However, if we want to monitor highly dynamic phenomena, highly dynamic natural phenomena, for instance, but not only, one problem we might have is that between the different acquisition required to produce a digital elevation model or a tomogram, the scene might change. And this is why it will be very important in the future to go towards single pass multi-baseline SAR interferometry and tomography, to go towards subsystems which are able to collect all the data required to produce a digital elevation model or a tomogram in a single pass, simultaneously. And if we now focus a moment on the generation of the digital elevation model, which seems easier, what we have seen before is that in TandemX, we needed two acquisitions, one with a smaller baseline and one with a larger baseline to produce accurate and robust DEM. So if we want to produce this DEM in a single pass, in principle, we would need a system like this with three satellites, like TerraSRX and TandemX flying information, three heavy satellite with a long antenna of about 5 meters. And this is something that is going to be costly, expensive, also difficult to operate in synchronization and so on. And my idea is that it would be most likely that this single pass system might be based in the future on clusters of small satellites, clusters of small satellites. And this is indeed the idea behind the project project is called Distributed Radar Interferometry and Tomography using clusters of small sat, DRITOX for short. This is a project funded by the European Union through an ERC grant that I am leading as principal investigator at DLR. And the idea of behind this project is that, for instance, in this case, we will have clusters of small satellites flying across the scene, collecting radar data. So all the satellite will receive the radar data. And then what we do, well, first we will do this range compression. And after we have done the range compression at each satellite, we will jointly process the data of all satellites through a sort of two-dimensional beamforming to create a three-dimensional radar image of the scene, so a tomogram. And from this tomogram, we will extract the digital elevation model that, as you can see from this first simulation example, looks very close to what the true topography is. An interesting feature of this concept based on the cluster of a small sat is that these clusters can be reconfigured. So here, for instance, I envision a cluster where we have some satellite in a long track and some satellite in a cross track, and this cluster can be reconfigured to serve some specific application. For instance, we can move them in a cross track to do tomography. We can move them as train in a long track to retrieve ocean surface currents using a long track SAR interferometry. We can even implement using this cluster some novel techniques such as multiple input, multiple output radar tomography, where we transmit from different point, and in this way we can retrieve additional information about the scattering mechanism, what you would not be able to do just using a simple conventional tomography. Last but not least, part of this project is the demonstration of these multi-static techniques using swarms of drones. Now, I guess I'm coming to the end of the time and of my talk, but if you like to hear more about this project, so this project started in June this year and will run for 5 years, there will be some dedicated talks here at the Apsar. Tomorrow morning, my colleague Mirjana Gustalli and myself will be sharing some first results in the session, I guess it's SAR and Radar System 1. So should you be interested in learning more, please feel free to join our talk. So I would like to thank you very much again, the Apsar committee for the invitation, the organization, and Hilam, Dr. Alimuddin, again, also from my side, it was really very kind from you, the support we got. And I would also like to thank you very much for your attention. So, thank you.
Thank you, Dr. Upendra, Dr. Michelle, please back to the stage. I would like to say thank you very much for your inspiring presentation, which also improve our knowledge and also add our insights regarding SAR technology currently and the future. Dear ladies and gentlemen, thank you very much for your attention to follow speakers from Dr. Upendra, Dr. Michelle Angelo, and Dr. Heru. Please again give a big applause to the speakers. Thank you.
Thank you, keynote speakers and moderator. But please wait, hold on. I would like to invite Professor Katsumi Hattori. Please join us on the stage to hand over the token of appreciation for the keynote speech and the moderator. And for Professor Heru will be represented by Dr. Wahyudi Hasbi. Okay, thank you very much, Professor Katsumi Hattori, Professor Ketuti Kantika, Dr. Upendra Singh, and Dr. Michelangelo Villano. Well, ladies and gentlemen, we have a great material from our outstanding line of speakers. The next agenda is time for lunch. We will have you will have lunch at Senses Restaurant at the first floor or ground floor on this building, and then please return to this room at 2:30 p.m. or 2:15. Okay. Please return to this room at 2:15. Thank you.
For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Contech will bring and show the space to the world. Enjoy your own space.
BIG has transformed substantially from 1938 to 2011. BIG holds the roles of regulator, implementer, coordinator. We prepare the data and regulation while also implementing them at the same time. Our duty is to prepare spatial policies that refer to the One Map policy. Guaranteed access to information. Credible information. Proper.
For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Contech will bring and show the space to the world. Enjoy your own space. For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Contech will bring and show the space to the world. Enjoy your own space.
BIG has transformed substantially from 1938 to 2011. BIG holds the roles of regulator, implementer, coordinator. We prepare the data and regulation while also implementing them at the same time. Our duty is to prepare spatial policies that refer to the One Map policy. Guaranteed access to information. Credible information. Proper.
For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. for anyone to enjoy every piece of space. Contech will bring and show the space to the world. Enjoy your own space. For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Contech will bring and show the space to the world. Enjoy your own space.
BIG has transformed substantially from 1938 to 2011. BIG holds the roles of regulator, implementer, coordinator. We prepare the data and regulation while also implementing them at the same time. Our duty is to prepare spatial policies that refer to the One Map policy. Guaranteed access to information. Credible information. Proper.
For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Contech will bring and show the space to the world. Enjoy your own space. For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Contech will bring and show the space to the world. Enjoy your own space.
BIG has transformed substantially from 1938 to 2011. BIG holds the roles of regulator, implementer, coordinator. We prepare the data and regulation while also implementing them at the same time. Our duty is to prepare spatial policies that refer to the One Map policy. Guaranteed access to information. Credible information. Proper.
For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Contech will bring and show the space to the world. Enjoy your own space. For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Contech will bring and show the space to the world. Enjoy your own space.
BIG has transformed substantially from 1938 to 2011. BIG holds the roles of regulator, implementer, coordinator. We prepare the data and regulation while also implementing them at the same time. Our duty is to prepare spatial policies that refer to the One Map policy. Guaranteed access to information. Credible information. Proper.
For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Contech will bring and show the space to the world. Enjoy your own space. For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Contech will bring and show the space to the world. Enjoy your own space.
BIG has transformed substantially from 1938 to 2011. BIG holds the roles of regulator, implementer, coordinator. We prepare the data and regulation while also implementing them at the same time. Our duty is to prepare spatial policies that refer to the One Map policy. Guaranteed access to information. Credible information. Proper.
For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Contech will bring and show the space to the world. Enjoy your own space. For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Contech will bring and show the space to the world. Enjoy your own space.
BIG has transformed substantially from 1938 to 2011. BIG holds the roles of regulator, implementer, coordinator. We prepare the data and regulation while also implementing them at the same time. Our duty is to prepare spatial policies that refer to the One Map policy. Guaranteed access to information. Credible information. Proper.
For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Contech will bring and show the space to the world. Enjoy your own space. For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Contech will bring and show the space to the world. Enjoy your own space.
BIG has transformed substantially from 1938 to 2011. BIG holds the roles of regulator, implementer, coordinator. We prepare the data and regulation while also implementing them at the same time. Our duty is to prepare spatial policies that refer to the One Map policy. Guaranteed access to information. Credible information. Proper.
For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. for anyone to enjoy every piece of space. Contech will bring and show the space to the world. Enjoy your own space. For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Contech will bring and show the space to the world. Enjoy your own space.
BIG has transformed substantially from 1938 to 2011. BIG holds the roles of regulator, implementer, coordinator. We prepare the data and regulation while also implementing them at the same time. Our duty is to prepare spatial policies that refer to the One Map policy. Guaranteed access to information. Credible information. Proper.
For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Contech will bring and show the space to the world. Enjoy your own space. For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Contech will bring and show the space to the world. Enjoy your own space.
BIG has transformed substantially from 1938 to 2011. BIG holds the roles of regulator, implementer, coordinator. We prepare the data and regulation while also implementing them at the same time. Our duty is to prepare spatial policies that refer to the One Map policy. Guaranteed access to information. Credible information. Proper.
For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Contech will bring and show the space to the world. Enjoy your own space. For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Contech will bring and show the space to the world. Enjoy your own space.
BIG has transformed substantially from 1938 to 2011. BIG holds the roles of regulator, implementer, coordinator. We prepare the data and regulation while also implementing them at the same time. Our duty is to prepare spatial policies that refer to the One Map policy. Guaranteed access to information. Credible information. Proper.
For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. for anyone to enjoy every piece of space. Contech will bring and show the space to the world. Enjoy your own space. For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Contech will bring and show the space to the world. Enjoy your own space.
BIG has transformed substantially from 1938 to 2011. BIG holds the roles of regulator, implementer, coordinator. We prepare the data and regulation while also implementing them at the same time. Our duty is to prepare spatial policies that refer to the One Map policy. Guaranteed access to information. Credible information. Proper.
For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Contech will bring and show the space to the world. Enjoy your own space. For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Contech will bring and show the space to the world. Enjoy your own space.
BIG has transformed substantially from 1938 to 2011. BIG holds the roles of regulator, implementer, coordinator. We prepare the data and regulation while also implementing them at the same time. Our duty is to prepare spatial policies that refer to the One Map policy. Guaranteed access to information. Credible information. Proper.
For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Contech will bring and show the space to the world. Enjoy your own space. For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Contech will bring and show the space to the world. Enjoy your own space.
BIG has transformed substantially from 1938 to 2011. BIG holds the roles of regulator, implementer, coordinator. We prepare the data and regulation while also implementing them at the same time. Our duty is to prepare spatial policies that refer to the One Map policy. Guaranteed access to information. Credible information. Proper.
For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. for anyone to enjoy every piece of space. Contech will bring and show the space to the world. Enjoy your own space. For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Contech will bring and show the space to the world. Enjoy your own space.
BIG has transformed substantially from 1938 to 2011. BIG holds the roles of regulator, implementer, coordinator. We prepare the data and regulation while also implementing them at the same time. Our duty is to prepare spatial policies that refer to the One Map policy. Guaranteed access to information. Credible information. Proper.
For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Contech will bring and show the space to the world. Enjoy your own space. For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Contech will bring and show the space to the world. Enjoy your own space.
BIG has transformed substantially from 1938 to 2011. BIG holds the roles of regulator, implementer, coordinator. We prepare the data and regulation while also implementing them at the same time. Our duty is to prepare spatial policies that refer to the One Map policy. Guaranteed access to information. Credible information. Proper.
For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Contech will bring and show the space to the world. Enjoy your own space. For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Contech will bring and show the space to the world. Enjoy your own space.
BIG has transformed substantially from 1938 to 2011. BIG holds the roles of regulator, implementer, coordinator. We prepare the data and regulation while also implementing them at the same time. Our duty is to prepare spatial policies that refer to the One Map policy. Guaranteed access to information. Credible information. Proper.
For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Contact will bring and show the space to the world. Enjoy your own space. For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Contact will bring and show the space to the world. Enjoy your own space.
BIG has transformed substantially from 1938 to 2011. BIG holds the roles of regulator, implementer, coordinator. We prepare the data and regulation while also implementing them at the same time. Our duty is to prepare spatial policies that refer to the One Map policy. Guaranteed access to information. Credible information. Proper.
For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Contact will bring and show the space to the world. Enjoy your own space. For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Contech will bring and show the space to the world. Enjoy your own space.
BIG has transformed substantially from 1938 to 2011. BIG holds the roles of regulator, implementer, coordinator. We prepare the data and regulation while also implementing them at the same time. Our duty is to prepare spatial policies that refer to the One Map policy. Guaranteed access to information. Credible information. Proper.
For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Contech will bring and show the space to the world. Enjoy your own space. For you who like space, we won't leave the space to your imagination. We will make everything happen in space. We will help your dream to reach space. We can make it in space. For anyone to enjoy every piece of space. Contech will bring and show the space to the world. Enjoy your own space.
BIG has transformed substantially from 1938 to 2011. BIG holds the roles of regulator, implementer, coordinator. We prepare the data and regulation while also implementing them at the same time. Our duty is to prepare spatial policies that refer to the One Map policy. Guaranteed access to information. Credible information. Proper.
Oscar, Dr.
Yes.
Oscar Gill.
How you doing?
Good. Finally, we have you. Can we have him on screen? Okay, we are testing before we start the session.
Okay.
We just want to make sure your voice and the connection is okay. You're live from where?
I am from Finland.
You live from Finland. Excellent.
Yes.
All right. Okay. I can see you. Can you show Dr. Oscar on the screen? We have a video camera connecting to, so you can see me. Can you see me now?
Yes, I can see you well. I can hear you well as well. I hear a little bit of an echo, but I don't know if you can hear me well there.
Well, we hear you. You can see that your face is on the screen.
Fantastic.
Fantastic. Your voice.
Yeah.
Would you share the screen yourself, or you would like us to do it? Because I already have a presentation.
I think I would like to share just so I can have control of the flow of the presentation.
Okay.
I can share right now just to see if it works.
All right, we just give you permission. Kasih dia yang share.
Okay, and I don't know if you can see the slides there.
Yes, unveiling the impact of the largest SAR commercial constellation.
Yes, no, it seems to be working quite well.
Yep.
So I did have a few questions for you. So one of them is like how you want to address questions, if the group will have any questions, or simply I will just provide my email and then any questions can be forwarded there. What do you think would be the best format?
Since this is a plenary session, we actually don't accommodate question and answer session, but we'll see if you can have your presentation within 25 minutes or not more than that. Then we will have some extra time for somebody or two person to question. All right?
Perfect.
Will that be fine? So
yes.
You can maximize your presentation, and we'll see if somebody is so eager to talk and question, then we will give him a chance. All right?
Perfect.
Perfect.
Yep.
Your turn is the second speaker. So there'll be a first speaker talking half an hour, and then after that, your turn, and then the third speaker will be another half an hour.
Perfect. So we're talking about like 40 minutes from now, right? That we will start with my session.
We'll start within, that's the average time for your turn. But you can also, of course, be and then looking at the other speakers as well.
Okay, perfect. I will do that then. So I think we have the camera working, we have the presentation working. So maybe now I will just deactivate my camera and the mic. I will still be available. Anything else that we want to discuss before we start for my turn?
No, I think that's all. We just have to make sure that everything is perfect running while waiting for your turn.
Perfect. So I will be online. I will deactivate the camera, and then I will just wait for the first talk to happen. And then I will jump on this, minutes before I will turn on my camera.
Excellent.
Sounds good?
Yes, sounds good. Thank you, Oscar.
No, thanks a lot. And again, sorry for not being present physically there. Thanks a lot for organizing this.
No worries. It's our pleasure to have you as one of our speakers. Thank you, sir.
Amazing. Thank you.
Okay, ladies and gentlemen, welcome back again to this room, and welcome back again to Apsar 2023. The Apsar 2023 and iCares 2023 are sponsored by Meta Sensing, Geospatial Information Agency of Indonesia, Contact, and Nextway. And also supporting organizations by IEEE GRSS, IEEE Indonesia Section, IEEE GRSS Indonesia Section, IEEE Communication Society, chapter IEEE Communication Society Indonesia chapter, Indonesian Society for Remote Sensing, and Chiba University. Ladies and gentlemen, the second session of plenary session will be moderated by Dr. Ilham Alimuddin. Please welcome Dr. Ilham Alimuddin.
Satu, tes 1, 2. Oke, everything set. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And good afternoon after lunch to all of you. This is timing where people tends to take a rest, but then we have to go on with our agenda. Allow me as the moderator for the second session of our plenary today. If in the first plenary you watch our keynote speakers, Dr. Upendra, Dr. Michelangelo, and then we have online Dr. Heru with us. For these plenary talks, we also have 3 speakers, and they are very prominent in terms of their role in SAR application and technology. So, ladies and gentlemen, before I call upon the 3 speakers, allow me to greet you this afternoon that I hope you are all wake up for this event. My name is Ilham Alimuddin. If Prof. Ketut is actually originally from here, I am not. I am from the other island of Bali. I come from the island of Sulawesi, in the southern part of Sulawesi called Makassar. Makassar, where my university stand as Hasanuddin University. So as you see, this conference is actually supported by prominent universities as well, the local as well as also connected with other islands. So we have ITB, ITS, and also Hasanuddin University, where I belong. We all try to take our role in this remote sensing society, where we can all participate research, technology, and applications for the lecturers as well as researchers. And most important is our students. Ladies and gentlemen, we are about to start. We have 3 speakers. The first speaker will be our head of the Geospatial Agency in Indonesia. We are very happy to have him in person. Coming here, Professor Aris Marfai. I would like to invite Prof. Aris to come over to the stage. Yes. Yeah. Thank you. And while waiting for him on the stage, just read a little bit of, can you show the slides over there? Yeah. The opening slides of Prof. Aris. So, welcome, sir. Really nice having you here. Thank you. All right. Just a little bit of his biography, short ones. Of course, he has a very long ones actually as well. Professor Dr. Renat Muhammad Aris Marfai is a professor at the Faculty of Geography at Gadjah Mada University. He got his professorship at a very early age, at 37 years old, very young, and got some award as well for his education, graduated from Gadjah Mada University. This is also in Java. And continue his master's in University of Twente, Netherlands. Master of Science in the field of Earth System Analysis at Institute of Geoinformation Science and Earth Observation in ITC, Netherlands. That's done in 2001 and 2003. That's quite a long time ago, actually. I was doing my master's as well. Yeah. No, you're not. You look young very well. And of course, his PhD is from Germany. I believe he speaks both Dutch and German as well. Okay. Gisian, yeah, in geography predicate. And he finished with the magna cum laude. Give your hands with him. Wow. And in terms of work experience, he started at the Faculty of Geography from 1999 to 21. He served as the head of the Foreign Cooperation Bureau, as well as the chairman of the master's program in coastal and watershed planning and management. Yeah. And before he became the Geospatial Information Agency head, he was the vice dean for research and community service and alumni and the dean of the Faculty of Geography in Gadjah Mada University. And now he is having the job from the country, from Indonesia, as the head of the Geospatial Information Agency, starting 2021, 2 years ago. Well, I believe that's just to introduce who you are. And now time is yours to present your paper. He will be talking about the potential use of airborne SAR interferometry for the acceleration of the nationwide large-scale topographic-based mapping in Indonesia. And this is very significant for our effort to map Indonesian in a very detailed topography. Yes, I believe that's what he's going to be talking. Thank you, ladies and gentlemen, Professor Aris Marfai.
Shall I come to the podium? Oh, here. Okay. Okay. Allow me to stand up because the men are look from how can they stand up or not. I mean, kalau Indonesia itu laki-laki bisa dilihat dia bisa berdiri apa tidak. I could not find in English, sorry. So good afternoon, ladies and gentlemen. It's quite challenge, big challenge to give talk after lunch. Everybody understand it. If there is coffee in front of you, it's better drink coffee. Ladies and gentlemen, my talk is related to the potential use of airborne SAR interferometry for the acceleration of nationwide large-scale topographic map in Indonesia. Actually, this material has been compiled by Pak Ade, Dr. Ade Komara is here, there. Yes, and also Pak Vivek. So thanks for the compiling this material. Let me start with the pakai situ aja ya, situ jalan aja, oke ya. Introduction. We in Indonesia currently, let me introduce myself first. I am come from the, as mentioned by Pak Ilham, the Indonesian Geospatial Information Agencies. This agency has responsibility to conduct the geospatial information nationwide in Indonesia, and responsibility direct under the president. So right now, currently, we understand that it is very needed, urged to have the large-scale base map in Indonesia, topographic map, on a scale 1/5000. We don't have yet on the entire Indonesia. So why it is needed? Because for our regional planning, for our land cover monitoring, for disaster management, it's needed the large-scale map. Simply because Indonesia is too large, the land area is consists 1.9 million kilometers square. Again, 1.9 million kilometers square is really huge. In order to map in a very detailed 5,000, for example, it's really need effort. This map production later on will be used as well to facilitate investment in Indonesia. For example, we will integrate this to the what we call online single submission. So the one of the important effort actually to conduct this large scale map is by using or have one of the option using the airborne INSAR technology. This is to accelerate the provision of national-wide large-scale base map of Indonesia. As I mentioned, there is some program that actually really depend on this large-scale map, which is multi-scale topographic base map and its main utilization in Indonesia. We have one map policy, for example, in national-wide, 150,000 scale. But then we have also development of the new harbor, for example, tollout, as well as I mentioned, the spatial planning. We need the detailed one. And for this detail, we need the large scale map. Smart city later on, we will also facing with this one. We should also provide the geospatial data in order to develop the smart city in Indonesia, as well as actually the hot issue, we have also to provide our new capital with the large scale map. So the important role and the urgency of the acceleration program in the provision of the national-wide large-scale base map 5,000 is, again, as I mentioned, we have to support the spatial planning, to support the investment, also to support the disaster mitigation, support one map policy, etc., and so on. The challenge is the geographical characteristic in Indonesia are really complex and diverse. We have various different landscape, geomorphological context, geological context are very varied. Challenges from the mountainous area up to the coastal area, disparate from the corner to the other corner, from the land to the islands, etc., and so on. If we mapping all the Indonesia, will be around 8.3 million kilometers square. But if we are mapping only in the land, it's around 1.9 million kilometers square. This includes 70,000 islands that we have also doing the mapping. And again, as I mentioned, the topographic variety is from the flat to the mountainous area up to 6,500 meters. Don't forget, some of the area are covered by cloud, and some certain area also almost permanently covered by cloud. That is also quite challenge for us if we are doing mapping, for example, only using the satellite images. Because we are very big, then it's also quite challenging related to the huge volume of data, including later on the processing, the handling, the management, the updating, etc., and so on. So this actually all are depend on BIG, how we can manage all those things. For example, let me give you another example. This is the picture of the coverage and average height of cloud in Indonesia. Before this, the minimum cloud coverage is relatively only 2 months. So we have only very short, very niche area. And the level of cloud is also different. We have very high, more than 7,000 meter. We have the medium one from 2,000 up to 7 meter, but we have also very low level clouds up to 2,000 meter. So the different characteristic of the cloud is also force us to think which is the best method, what are the best and appropriate method to do the mapping in Indonesia. This is the one side. The second side also our land cover is diverse. If we see the complex environment and this differs the landscape in Indonesia, this is also quite challenging. If later on we will also apply it, for example, on the data extraction using, let's say, automatic future assessment, automatic future machine, etc., and so on, because the typical of the landscape are very diverse. For example, we have dense settlement, as you can see in the picture. We have also, this is the kind of the settlement in Indonesia. We have also small road in slum settlement. We have what we call multi-story building. We have also dense slum settlement. Quite challenging for the automatic feature extraction to do this kind of thing. For example, also we have House is covered by the trees on the next, yeah, and also the geometry, different kind of geometry, various roof types and material is also influence us when we are doing the mapping. So, ladies and gentlemen, that is the picture of the availability of the multi-scale Indonesian national base map up to now. We are finished already 50,000 for entire Indonesia. In some extent, this really been really useful in order to help to support the government in doing the regional planning, in doing the regional assessment for disaster management, in doing the regional analysis for the natural resources management, for example. But in some extent, we need also more detailed scale. We are finishing already 25,000 only entire the Java, but not yet in different island, in other islands. Again, we are very small, around 50,000 kilometers square with the large image, with the large map, which is 5,000 scale. Meaning that's only less than 3% of Indonesia total area have already covered with the large scale. Though BIG in our office, we are doing this already since 2013 because simply this need much more effort, budgeting, etc. and so on. Our office called big, but we are not really big enough office, yeah, because we only consist 700 people and with 12 different activities, 12 different centers, and this mapping activity is only one center among these 12 centers. So you can imagine our budget also not so high. We have to divide it into different purposes. Therefore, we are now trying to find another way, breakthrough, how to manage to get large scale accelerated. I will show you that. The next picture is availability and coverage BIG large scale, as I mentioned. So we spent already 1.2 trillion rupiah over 7 years for the large scale base map 5,000, mostly using aerial photogrammetric and LiDAR technology for sure with the traditional stereo plotting method, and also we are so far only producing around 2.5% of the Indonesian land area. We need more effort. In different area, we are doing with the Citra satellite resolusi tinggi, the high resolution satellite images, but another area, for example, we use also aerial photograph, and we use also since 2015 up to 2020 combination between the aerial photograph and LiDAR. Ladies and gentlemen, if we have a look the result actually comparing to the Google map, for example, if we have looked at the Kota Depok, our map is actually more detailed geospatial information rather than Google. The thing is only we are not covering yet all the entire Indonesia. Google already covering almost entire Indonesia with a very informative point of view, but very maybe less or not so precision compared to our map. Our product contains 3D feature and hypsographic layer, and this is somehow some extent really useful and help us to do many kind of analysis. We did also the geometrically more accurate using adequate GGP, current control points, and for sure more reliable because this is produced by authorized national mapping agencies. Again, another example, Kebun Raya Bogor. We can compare our map with the Google map. And those are a very detailed one. We have more information, but again, there is covered only the small area that we have. Google has another corner we don't have. But let me show you another picture. We have also 3D based map of the in a certain area, for example. In our project 5,000, we will create this all entire in Indonesia. So you can imagine this really huge geo big data later on. Another example in Kota Palangkaraya with different 3D map, as well as I mentioned, we are also supporting the Ibu Kota Nusantara, capital city of Indonesia, with aerial photo and LiDAR acquisition based map. we just recently done in 2019 and also updating 2023. This geospatial data acquisition technology, for example, as I mentioned, we are facing with the cloud covered almost permanently in some part of the Indonesia. That's why we try to use the active sensor, for example, the microwave or radar, or use the sensor platform that low, for example, low flying height under 2,000 meter, for example, such as using drone or aircraft. So, meaning that a combination of the aerial photo like iPhone SAR, high resolution satellite imagery method will likely be the most, in our case, the most effective approach to achieve detailed and comprehensive base mapping coverage of Indonesia. This is the comparison, the geospatial data acquisition technology for large-scale base map production. For sure, if we are talking the ideal one, it would be good to have all the entire Indonesia with aerial photo and a combination with LiDAR. But again, it's really very costly. Very costly, yeah? Then we try also to have look another method, which is also using airborne SAR, the synthetic aperture radar. So by having the combination, we try to find the optimum, the trademark where we can spend our budget in the same time we can cover entire Indonesia. If not, then we can also use the high resolution satellite imagery, for example. So those kind of comparison in our analysis, how we can do our mapping with the different ways in order to get the output of our basic geospatial information, which is the output according to the regulation is the building and public facilities, transportation and utilities, hypsography, hydrography, coastline, land cover, toponymic as well as administrative boundary. For sure, of course, with the 3D and or two-dimensional seamless geodatabase. So those are that we would like to get it in the next 2 or 3 years. Comparison between the relative cost and accuracy of digital elevation model generation technology. For example, if we using the airborne INSAR or interferometric synthetic aperture radar, this is the ideal one. But for sure, this, as I mentioned, need more effort. That's why we try to combine with, for example, airborne stereo SAR, both airborne INSAR and stereo SAR use radar to produce 3D images of the terrain. However, the stereo SAR is actually relies on the physical separation. As you know, maybe you aware already that the separation between the two radar antennas to produce the data, which might be less accurate than the interferometric approach in LASAR. So, meaning this airborne INSAR could be more cost effective because it requires only one radar antenna. We use also another satellite stereo SAR, high resolution optical satellite, etc. and so on. So airborne INSAR, in this case, offer high accuracy in terrain elevation data and is relatively cost effective compared to other technologies such as LiDAR. In terms of the cost effective technology for regional scale topographic map, for example, this for regional scale mapping, such as countrywide of Indonesia, for example, where high spatial and vertical accuracy is required, we need to spend because of our variety of the morphology. Might be airborne INSAR and airborne stereo SAR is considered to be more appropriate to do this one, especially if the topographic information is necessary for it. And for sure, for our topographic map, this is necessary. So far, ladies and gentlemen, the status of airborne INSAR data availability throughout the Indonesia. We providing the data actually since 2000 or since 97, but on a very small area. Then again, up to 2012, we are still producing this one with the coverage of some part of the Indonesia. Meaning that actually starting from 97, we are already exercising this technology to do the mapping in Indonesia. So the development of airborne INSAR technology, as you can see, we are starting already from mapping the Java and Papua in 97 using this INSAR with 3 up to 5 meter vertical resolution, and also in Sulawesi, Bali, and Nusa Tenggara in 2003. And so later on also 2005 in Sumatra, Kalimantan, Java, Nusa Tenggara, and so on. So the largest scale base map using airborne INSAR data ever made in Indonesia up to 2012, for example, was in the scale 10,000, especially for mapping area prone to earthquake and tsunami in the west of coast of the Sumatra. So for particular purpose, we use the airborne INSAR. By that time, with the combination of the QuickBook with the spatial resolution, almost a half meter. So just to give you an example of the airborne INSAR derived large-scale base map 10,000 in Indonesia, for example, we have different type of peta rupa bumi or our base map. This map are done by the photogrammetric from Apsar in 2008, and also in combining with the QuickBook to help assessment of this map, especially QuickBook 2008 and 2010. Also another example, the medium scale 25,000 we have done as well using INSAR in Kartanegara, in Yogyakarta, as well as in Lombok Tengah. So when we are doing the INSAR, so we are following the kind of the processing workflow of the raw data collection and SAR processing. So starting from the raw data collection, which is collected by flying a SAR system in our case, as well as later on the data processing, which is consists of the calibration. For sure, we have to do that. Q location as well as the terrain correction. So those flow is just to give you an example and description how we are doing with our INSAR in PIG. For sure, there is also another approaches and method to do this activity. Main application of INSAR in topographic and deformation mapping is also having done in PIG. This processing stage of airborne SAR to produce ortho-rectified radar image or ORI and digital surface model by doing the interferometric SAR processing, also with the step of fire formation for registration, interferogram generation, and also pass and wrapping, etc. and so on. So this picture just give you an example how we are doing this INSAR mapping for our topographic and deformation mapping, as well as later on we use also airborne INSAR derived topo-based map production. This is kind of the traditional stereomate plotting approach that we have done, we are doing in PIG. This traditional stereomate plotting approach consists of airborne INSAR acquisition, and then later on the creation, use the creative stereo pair, for example, to have the overlapping images, etc. and so on. And then also to have the stereomate plotting, the data compilation. This traditional stereomate plotting approach to generate accurate topographic map can be what we call, it's considered as labor intensive and time consuming, and generating precise digital elevation model requires specialist software and skilled personnel to do that. So we are aware of this. That's why we doing in combination with what we call automatic feature extraction. Again, though this also quite challenging when we have but we have quite different land cover and characteristics in Indonesia. There is another business process that we are doing in combination airborne INSAR with automated feature extraction to accelerate the approach. This has been used to provide the large-scale map in Indonesia. Automatic feature extraction is considered the process of automatically extracting and classifying various geographical features from remote sensing data. This can include, for example, extracting topographic features such as road, building, river, vegetation, etc. and so on. So in the case of Indonesia, which has a vast and diverse landscape, the use of couple airborne SAR, as I mentioned, and this automatic feature extraction can greatly accelerate the process of mapping of the entire Indonesia. This approach can provide essential information for various applications such as urban planning, such as disaster management, and so on. This is the next picture. So as the 7 area of interest block for open rural forest classification. We do this classification in order to speed up the process on mapping the large scale. This characteristic, this classification consists of urban area, rural, and forest. And we try to map those different things. In urban area, we use class first base map, and then rural second class base map, and the forest the third class. Unfortunately, the class third class are the biggest one in entire Indonesia. So we try to make it into different 7 blocks, which is Sumatera, Kalimantan, Java, Bali, Nusa Tenggara, in one aspect, Sulawesi, Maluku, and as well as the Papua. This is our project. So we do this, the acceleration program on the large scale. In summarize in this table, more or less, this project timeline, the acquisition starting from tomorrow, the next year up to 2025, 2 years. We understand that we need more effort, a lot of things, a lot of partnership, support by a lot of company, people, etc. and so on. And we predicted more than 4,000 people are also involved in this activity. Also in 3D-based map production, immediately we start 2024 when we have already the first data from the acquisition process. So up to 2028, as I mentioned, the previous images about the 3-dimensional building, we will do like this for entire Indonesia. And we will do this by multi-year contract, start 2025 up to 2029. We are now in preparing this one. Area of interest, the whole nation, and total area 1.9 billion kilometers square, urban around 90,000, and then rural around 840,000, the forest around almost 1 million kilometers square. So in the infrastructure, we use tier 3 IT infrastructure, also cloud-based and high-end base map production technology. We expected to have this one, as well as the high-end ICT facilities. As I mentioned, BIG is big, but it's not really big in terms of our funding. That's why we have the combination with the Rupiah Murni or the APBN, the national budget, as well as also in the loan. In this case, from the World Bank, we will start from the World Bank soon, 2024, and then 2025, and so on, as well as we are incorporating with the state-owned enterprise, with BUMN. We are already discussed this with the BUMN. We are preparing all the necessary administrative thing, papers, etc., and so on. And hopefully we'll come up with this next year with the own enterprise or BUMN. And this BUMN will cover around Java and Nusa Tenggara. So which is the one that can be easily monetizing for this BUMN itself. The data acquisition technology for the urban area, we need the aerial photo and LiDAR. It's very costly. That's why we could not cover entire Indonesia. But rural and forest, we will do by airborne SAT, our topic today, which is a synthetic aperture radar, and also combining with the high resolution satellite images. Base map production technology, we use spatial artificial intelligence, as well as the, if it is not automatic feature extraction, then semi-automatic feature extraction, because we still need giving guiding to this feature, to this machine, etc. and so on. But we will do this one. It's quite challenging as well, because the experts on this issue in our office is also not so many. So we are also on discussing and thinking how to fulfill this issue. Deliverable product, we do the imageries, ortho-rectified radar imageries, as well as color ortho-rectified radar imageries and optical orthophoto. We'll produce as well multi-scale 3D based map, as I mentioned, which is the level 3 and also LOD level 1, for example. For sure, as always, we product DEM, consists of DSM, surface model, terrain model, and point cloud lidar. Hopefully, that the base map horizontal accuracy on the urban area would be around 1.5 and less for the rural as well as less for the forest area. So the acceleration program in the provision large-scale map, this is the project timeline and planning, as I mentioned. This is just summary as I talked before. So we starting 2004 up to 2006 with the Apsar, Utara, and Ladder, and also again continuously up to 2027, and also the very end, we do also base map utilization and commercialization. Without this commercialization, we could not do updating very often. So this is the way we can manage putting the updating in our map. This is the automatic multi-scale topographic base map production. It's also already mentioned before. And then I just continues to the example of the large-scale 3D that we have. Next slide. And this is, for example, Complex Nayan, the national-wide large-scale 3D Indonesia. If again, with success with 3 years to conduct this large scale with all the product, so the big dreams come true through PIG, and aspirations are successfully realized. Indonesia will have what we call one of the best national geospatial data set in the world. We can come up this way. As a conclusion, sorry to have 1 more minute. By law, PIG is mandated to provide national-wide multi-scale base map throughout the Indonesia, as we understand. The provision of the national-wide multi-scale topographic map, which is 1.5 thousand. If we have 1.5 thousand, and then automatically we can conduct it to 25,000, 50,000, and so on. Is mandated by law number 11/2020, is urgently required to support national strategic development goal with special emphasis on national spatial planning program. In the case of Indonesia, which has vast and diverse landscape, the use of coupled airborne INSAR and automatic feature extraction can greatly accelerate the process of mapping itself on the entire country at large scale. And the use of the technology combination of geospatial data acquisition, for example, using the combination of aerial photo, using the metric camera and LiDAR in urban area, using airborne INSAR and high-resolution optical satellite images for rural and forest area, for example. So far is considered as the most co-effective and efficient due to the limited availability national resources, due to the tight project timeline schedule, and due to the low capacity of national industry in the field of survey and mapping, as well as due to the data quality and compliance with the technical specification of large-scale base map and limited budget availability. Thank you so much. Sorry.
Thank you, sir. No, you are right on time, actually. Thank you, Professor Aris Marfai. Prof, I remembered when I was still a student, I have to digitize the map using the Calcir. If you remember that, right? How the advancement of technology really now, my students, they don't have to digitize anymore. They just grab the digital data directly from the geoportal, from DIG. So it's an excellent technology. Then we come to that kind of advancements of doing the maps. Ladies and gentlemen, maybe I can have 1 question from the floor before I move to the next speakers, because we don't have that plenty of time. Professor Dr. Arif and Pak Hartoko, okay. Very short questions. Shall I give you the...
Yeah. I'm just wondering if Arif could explain are you using GIS data in doing the maps, or just only
Only providing the remote
certain limit of information. If you are talking about map, are you putting a lot of kind layer or factors, whatever? First,
So not only the raw data, yeah?
yeah. Secondly, that the maps is kind of stochastic process. In other words, it change all the time, right? So
Dynamic.
how do you what do you think to maintain it? In other words, is there any effort within its plan or something like that to maintain the updating?
The updating. Thank you, Dr. Arifin. Hold on, I have one question before we can answer the question.
Thank you very much, Professor Aris, Professor Toko from the Ponorogo University. As you have elaborated that need of the land-based 5,000 kilometer scale mapping is the focus and the important one in this time, in this period. That is nothing wrong with that. But my question, is there any or what kind of program that dealing with marine-based mapping? For example, blue carbon, anything like that, in within 12-mile zone. Is that in the coverage of BIG or in marine fisheries minister?
Dr. R. Toko, eh? No. Yeah, all right. Two persons with three questions, Professor Aris. So you can address just quickly on this.
Yeah.
Yeah. Time is yours.
Thanks, Pak
Arifin.
For sure, when we are dealing with the geospatial data, we need the software. We could not do based on culture as mentioned by Pak Ilham. This is already really obsolete the zaman batu. So in doing so, we need some the extended or advanced software, and we are now exercising those kind of different software because, in particular, data acquisition process might be suited with the particular or certain software. But for sure, we use GIS on this in order to compile our map, to develop the map itself, or later on when we are doing the analysis. I just tell you, our dream is actually when we are finishing this, we are not providing this material for you all guys using the download system. So we'll provide this in terms of web services, so everybody can doing in this webs without downloaded this material. Yes, for source in some extent you can download it. This means just to avoid the unnecessary and redundancy or mistaken information. You can imagine 1,000 students downloaded this kind of map, and then we have 1,000 version of map. And then it's become a challenge for us to believe which one is the most appropriate. So in doing so, we need the JS technology. And then the second question was, the changes, the dynamic land cover. This is the one of the challenges in our case. For the urban area, this very rapid change. That's why we later on, when we are finishing this one, we are providing this for what we call monetizing, capitalizing this. We can earn money from this, not us in PIG, but the certain company on the cooperation with the BUMN. They will create some money. This money can be used for updating the process because we could not rely on the APBN money as always every time. So that is the dream, and this is the very beautiful cycles of this map protection in us. Yes, for the certain area, LiDAR is very promising right to now, up to now. But again, this is very expensive. That's why might be in the combination, for example, the airborne SAR would be very useful in this case and very beautiful to have this combination. We do not yet, we don't know yet in the near future if this has become easy to have LiDAR become very cheap as a time on. For sure, we will adapt with this kind of condition. But for sure, we do this updating. In the urban area, it might be every year, for example, but in the forest or in the rural area, it might be more than 2 years, 3 years as a trend. It really depend. Also depend on the request. This is the certain area, a particular to disaster, and then it is request to do that, and then we are doing this kind of thing.
It should be like that.
So,
Yeah.
quite
Last one
challenge
is
and the
thematic.
last one,
Thematic maps, blue carbon maps, and how
Okay.
it becomes.
Yeah. Let me inform you. DIG has the mandate from the Undang-Undang 4 2011 to conduct the geospatial information, meaning to create the base map, which is as the base geospatial information, and also to help accompanying the other agencies and minister to conduct thematic map. Bapak Ibu, bahasa mudahnya geospatial informasi dasar yang peta rupa bumi itu belong to us, we have to make it, but informasi geospatial thematic belong to the ministerial agencies and other agencies. For example, we have a mangrove map, is belong to the forestry environment. You have the transportation map, you have to the Ministry of Transportation, you have many things, etc. and so on, name it, you can mention. But we in BIG is responsible to accompanying them in order to make sure that they are doing in the correct way on the standardization, on the norma, on the procedure, on the metadata, etc. and so on. So that's why we are creating the rule to do that and help. As well as we are responsible if the thematic map has not yet the valid data or there is no responsible agencies to do that. For example, we have the map of land system. Land system is not belong to one of other ministers, so that's belong to us. Or if the president ordered us on the certain area, for example, it was in the earthquake in Palu, the president ordered us to do the mapping, then we are doing the map, the thematic map.
Okay,
yeah, thank you.
Excellent. Ladies and gentlemen, give your round applause to Professor Aris, and thank you for your presentation for this plenary talk. And now you can go back to your seat. Thank you, ladies and gentlemen. Let's proceed to our next speakers, who is online with us already. Dr. Oscar Jill, can you say something for a start and show?
Yes, so hello.
Excellent. How are you? Good.
I'm great, excited to join the conference, and well, apologize for not being able to be physically present there.
Yes.
But hopefully I can do a good job on the presentation and match the good level of the previous presentation.
Okay, Dr. Oscar, let me just read a little bit of your biography before we start. Thank you for waiting. You look nice over there. Dr. Oscar is from Finland, living from Finland. Dr. Oscar, education is from University of Simon Bolivar as an electronic engineer, and finished his master's in space engineering from Tekniska Universitet. So it's a Finland university somewhere. And his experience now working in ICE, starting from electronic hardware designer, then an IT electrical team leader, a senior mission manager, and finally now he's the director of spacecraft engineering until now. Dr. Jill, Dr. Oscar Jill, actually also is an engineering advisor for quite some time, as well as working in the National Instruments. Wow. So, Dr. Oscar, you really are in the business area in terms of SAR application. So, we already had one speaker who talks from the government side. Now it is your turn to talk from the commercial sides. Can you show the slides? Are you going to share your own slides? Yeah.
Yes, I will be sharing. Maybe before I start, well, I will definitely be presenting a little bit more of the commercial side. I used to be a very technical engineer, but now have transitioned maybe a more managerial position. And yeah, as you have mentioned, I joined ISI very early in its creation when it was a startup. We had around 20 people back then, and now we have about 600 people. So been quite a journey for me from the very beginning of the organization all the way now where we have the biggest SAR constellation, all the way from an intern and an electronic designer to director. So quite a little bit of a change. Not quite there, a doctor, but hopefully in the future that will be the case. I have finished my master's and now on the next step of my academic formation and career. And yeah, so let me maybe start by sharing my screen and you let me know if you can see it. So guys, you can see it okay? Can you hear me? Dr. Ilham, I don't know if you can see my screen, if you guys can see my screen, and if you can hear me.
Yes, we can hear you. And your slides is okay.
Okay, perfect. So we'll start.
About unveiling the impact of the largest SAR commercial constellation, right?
Correct.
Time is yours.
Fantastic. So yeah, we are going to be talking a little bit about the company, the organization, and the application of SAR products. Right now, ISA is one of the biggest players in the SAR market, and we have, I think at the moment, the biggest SAR constellation with over 20 satellites. I will talk about our platform, about the different image modes and SAR modes that we have available, and the applications of those SAR modes. And also, I will be talking a little bit about the power of the constellation, how the constellation unlocks the ability to actually have close or near real time. Before, let's start a bit about ISI. So our vision is to deliver persistent monitoring systems for truly effective change detection. Basically, we want to enable better decision-making by providing our clients with timely and reliable Earth observation data. So that in practice means that we want to produce as much high-quality data as soon as possible so our clients can make better and faster decision-making. Usually those decisions lead to saving life, to improving the quality of life of others, diminishing the loss of infrastructure, and so on. Most of you are SAR experts, so I'm not going to dive into the details of the basics of SAR. But as you know, compared to optical systems, SAR has the advantage that since we create our own source of energy, we don't rely on the sunlight to take the images. And on top of that, because of the properties or X-band wave, we can actually see through clouds. So a lot of applications, and especially very prominent on the natural disasters a topic, making allusion to the previous presentation. A little bit more about the company in a nutshell. So we launched the first small SAR satellite in 2018. So the first one in the world of that particular size. We have 4 subsidiaries in Poland, US, UK, and Spain, and our main headquarters is in Finland, in Helsinki. And we have over 500 people. These slides are a little bit old, but we have about 500 to 550 people at the moment, and over 60 nationalities. And I want to maybe make an emphasis on the diversity of the organization, because I truly believe that that is a success. I am not originally from Finland, for example, so just an example, as a sign of that diversity that we have in the organization. We have raised funds since 2015, more than 300 millions, and we have multiple clients internationally, both on the public sector and the private sector, and trying to provide data and solutions to basically enable that better decision-making that it was mentioned before. So let's talk about the platform that we have in particular. So the first thing to mention is that it's a flat panel phase array antenna, and it's a very small form factor. So we're talking about a platform that has about 1 meter by 1 meter on the bus, and the antenna has about 1.36 square meters. And the most important element is that we have electronic beam steering capabilities. So by combining these 3 things, we actually have a quite versatile platform that allows to have images in many forms and shapes, basically a lot of SAR modes, a lot of image modes that we can provide. We can do fast turning because the structure is rigid. It also settles quite quick and have high coverage. So by combining that beam steering capabilities and the mechanical steering capabilities, we reach to all these modes that I'm going to present and talk a little bit about later on. Other maybe more classic SAR systems that have a deployable antenna on orbit those deployable structures usually are not rigid, so they have a slower settle time. And because they have a higher moment of inertia caused by the bigger antenna, also tend to be a little bit slower. They also have some limited beam steering capabilities, which reduces the coverage that one single platform can do. I will show you in pictures what exactly the platform looks like. And this is one of our generation 3 satellites. And this is the one that we're providing to the market, and we're providing images and platforms to clients all around the world. Pretty basic standard elements of regular satellites, solar panels, the antennas. We have a bandwidth of 600 megahertz and 500 megabits per second X-band downlink. Particularly important, as you guys know, when we have raw data of this size of 600 megahertz, it started to be quite heavy, and then we need to have the capabilities to download it quite quickly. And we have an X-band steering downlink antenna, which basically means that we can track the ground station while we're taking an image. So that translates on taking an image close to the ground station and downloading the data almost simultaneously, which gives us access to give the data immediately to the client without waiting to have a full orbit to reach the ground station. Now I talk about the different modes and the versatility of this type of platform, and what better way to do it than showing it on pictures. So this is an example of all the image modes that we have, and I will go through all of them, but we can go up to 50 centimeters resolution, which is quite a high resolution, and up to 50,000 square kilometers of coverage. So in our biggest image mode, the scan, we can reach to those high coverage areas with resolution of 15 meters. And as we go to higher resolutions and smaller areas, all the way to 5 by 5, 0.5 meters of 50 centimeters resolution. Okay, so let's dive into each mode and how do they work and how the platform itself allows for these image modes. So we're going to start with scan mode. And basically what we do in scan mode is that we take advantage of the beam steering capabilities while our satellite goes all the way through the azimuth track, and then we continue imaging through azimuth, and they use the beam steering to have quick looks towards the range. So we took different looks going through range direction, and allow us to build quite a big scene. This is where we get those 50,000 square kilometers that we discussed. So really amazing application to take look at big areas, particularly good for maritime route checking, maritime solutions, identifying vessels that are not supposed to be there, and also to track high areas of border, or even in the country when there is a natural disaster. You can start to identify where are the points of interest, and then have additional images that are higher resolution to define better the details. The street mode is pretty much similar, but we don't use the beam steering, but rather we focus additional power to increase our average power and get a higher quality picture. So we get higher resolutions, in this case, 3 meters resolution, and we can observe further detail, but still quite significantly large areas. So this is an example of a picture where we can see all the vessels. They are very easy identifiable. We can identify the size and the type of vessels that are there. And also extremely important for natural catastrophe, disaster, floods, earthquakes, fires, wildfires happening. So quite a practical image, and you can go from a scan to a strip to get further detail, and then we can go even higher in resolution. So spot modes is one of the most used target type of images, because allows to combine the mechanical steering of the satellite. So we take a really long time windows of imaging, and then we focus on a particular target while we are steering the satellite looking at the same target. So we get to reach to really high resolution images, and we can start to see real details and understand the different elements here. So I will go later in detail about this particular mode, but we can now start to identify objects. We can start to have fine resolution. We know exactly what we're looking at and what are these objects. Now, a little bit of a compromise is to use now the beam steering and the spot capabilities on those long viewing times, and we can start to have images that are quite large and still a very good resolution. So in this case, we have 1 meter resolutions for really big areas. On the previous mode, we have 50 centimeters resolution, but these are some examples of the closest market alternative of that resolution and the coverage areas that they have. So pretty much we cover several times those areas with similar resolution. So again, a compromise depending on whether you want to have finer detail or cover higher areas. And we're going to now enter into dual mode, which is a really cool mode. And I want to spend a little bit more time on this particular one, because here we are applying even further techniques to ensure that we can improve the quality of the image. So what we do in dual mode is basically we're having longer image windows, and we are having sub-apertures. So by combining those sub-apertures on different illumination degrees of illumination, we can actually start to compile them and observe the objects in further detail. We can also reduce the speckle noise because it's the same on every one of those apertures. So we subtract that noise, and on top of that, we start to see the details that are only observable from certain angles of incidence, from certain angles of illumination, and that's what allows to build higher quality images. So here on the left, a regular spotlight image, and you can see that there is a little bit of a speckle noise. We know that there is some kind of helipad there, but we're unable to identify the objects, whether those are helicopters or not. On the right is quite more noticeable exactly what we're looking at, the size of the man-made structures and the helicopters themselves, and we can start to identify targets, which is a great application on its own. But it can go a little bit further, and we can use additional techniques. So what I'm going to show you is what we call color image. And what we do is that we take all of those sub-apertures and assign different colors. So what happens is majority of the when we took an image on a particular area, and whether it's forest, whether it's land, anything that is nature made is going to be look more or less uniform from the different degrees of illumination. But the man-made structures are usually sharp angles and they're flat surfaces. So the there's less back scattering, and they appear like brighter in the image, and they will look different from different angles. So what we can do is that we can assign colors to those particular sub-apertures and then combine them in one particular image. So this is an example, and it's really cool to see here. We're basically seeing a forest, but because we have the ability to see from the different angles and compile the image, we can see that each one of those color dots represent gravestones. So each one of those is gravestones. And what is really cool to see here is that this is literally underneath a forest. It's impossible to see in a regular image. And I think the next image that I will show you is a little bit more clear what I'm discussing. So on the first one, we have a regular SAR image. We can see what it seems to be a parking lot with some cars there, some man-made structures in the south. But the moment that we use the color mode, the dual mode, we can start to see further details that before they were not present, or they were very hard to get. So we can start to see that there is a road, there are further structures under the trees that we were not able to see, and we can start to see vehicles under that forest ceiling. Now, since each one of those apertures basically is images, we can combine them to make a video, and then we can actually see changes through a one look. So in this case, we can see a vessel moving. So we can calculate the direction, the speed of rotation of this particular vessel. This is an example of one of the applications on how the SAR video can be used. So this is what we call SAR video, and it's part of a dual mode application. Now, when you are seeing from different degrees of illuminations, particularly in small objects that are below the resolution of the image, you can still see some of the highlights, like they can appear bright in the image, but you will see only parts of it. So by combining all of those sub-apertures, we can start to build the image and see really narrow objects. So it would be really hard to see this in a SAR image, in a single SAR scene, but here we can actually see all the power lines of this particular scene, which is really something unique. It would even be, depending on the resolution of the optical system, difficult to see this, but we can see it with SAR. Now, all of these image modes on their own are fantastic, but they cannot be taken advantage of unless we start to talk about the constellation itself and the power of the constellation. So ISI has more than 20 satellites, and we have a high coverage rate of the entire globe, and we have what they call ground track repeat. So that means that we can visit the same area constantly and actually keep track of change detection seeing what is happening in particular areas. So this is at the Port of Rotterdam particularly, and you can see boats moving, you can see activity happening on land. Let's take a deeper look at what's happening here. So here we can observe material being loaded and unloaded from the vessels that are parked, and we can see changes on the materials and those activities. This one is a really cool, amazing one, because you can actually see the level of the fuel tanks changing while vessels have been serviced and recharged with fuel. So this is just an example of that daily coherent ground track repeat and the applications that you can get there. But let's go a little bit deeper in how we can use this product. Now, when you have a steady source of the reliable data, you can start to do applications based on the data. So we're not stopping on just providing the raw data, but rather we're taking that data, we're processing it, and then we're also adding artificial intelligence models. We're applying additional data to complement the SAR capabilities, and we can start to do applications. So this is an example of one of those applications. In this case, is the ISI flow insight. So we can actually determine whether what is the level of water and depth water during floods. We can see the flood extent and the depth, and we can actually see what are the buildings that have been impacted. So that allows governments to have quicker response time, save lives, for insurance companies to make decisions about what is going, decisions regarding the insurance policies for the clients and improving the quality of life of the people that have been affected for the floods. We can even use as you guys know, right now we have a lot of wildfires going all around the globe. And they have the challenge that because they produce smoke, it's hard to track with images. You have to use infrared technology, but you can actually use SAR also to detect changes, and those changes into understanding how the fire is spreading and develop models or a spread of fire. Here we can see in purple areas where there is no change at the beginning, and then how slowly they start to change, meaning that the fire is extending to those areas, or from both sides to the center and the southeast. This is another example of change detection, and we have a volcano eruption, and we can say day by day how the volcano eruption evolves. And if we imagine this happening in a populated center, that will mean that, well, there will need to be relocations of citizens, and you would like to mitigate as much the loss of infrastructure. So this kind of data allows you to understand the spread of activities and natural disasters like this, and take actions to protect infrastructure and protect citizens and the people. Finally, I'm going to show you another application, which is for deforestation. So we can monitor, for example, and this is a segment of the Amazon that has been cut down slowly, and you can see the track and the progress of that. So this is just an example of the many applications that you can have in this type of with this type of product and with this massive volume of SAR data. So that's in a nutshell the presentation that I wanted to show to you and to bring up of the many applications that SAR can have and can improve lives. So I don't know how much time we will have for questions, but here's my email. So please feel free to reach out to ask any questions. And thank you so much for letting me be part of this amazing conference, and for the organizers to set up and allow me to present in a remote way. So thank you very much.
Thank you. Thank you, Oscar. Give my hands, Dr. Oscar. If you stay a little bit longer, I'll give you a session where the floor can ask you questions, because your presentation is like me watching the God's eyes in Fast and Furious movies. You know, you can see everything very clear. And the question is now, how do we get the images? Like me, very much interested on how you can map the flood, for example, how the changes and etc. We cannot ask actually that the disaster happens, then we can get the images from you, right? That would be a questions later, how well we can get these images from the perspective of business and commercial constellation, right, Dr. Oscar? So ladies and gentlemen, I would give you a little bit time for questions and answer, as to be fair with Dr. Oscar. Anybody? Yes, I'll give the floor our audience question if any of them would like to ask more. You can comment my question later. Okay, any questions from the floor? One question from Pak Ade and one from Mikhail. Can anyone help me with the mic somewhere there? Yes, thank you. Because I'll be running around. Yeah, the mic can still happen. Give it to Pak Ade first. Oh, okay, Mikhail first. All right.
Well,
Why you have to speak on the mic, because in order Oscar can listen.
It is impressive to have such a huge constellation, but how long do the satellite last? So how often do you need to replace, or do you plan to replace them? Just to get an idea. I understand this is difficult for each satellite. But...
Right. Yeah,
Yeah.
I think the question is clear. How long will
Yes,
the satellites?
I can answer right now. So
directly.
Yes. So our SARs are sized for 3 years of operation. So our strategy was to create platforms that can be easy to replace, easy to build. So actually take us less than a year to build these platforms. So they are manufactured very quickly. And that's basically a very well-defined decision that we have made in order to keep the technology up to date. That means that we can have a satellite that in 3 years will go out of service, but then we will have a replacement with the newest available technology. So the reality is that we're not trying to make satellites that last 10 or 20 years, but rather short times. 3 years is still quite a little bit of time, but in the sense of all the space is significantly less. But that is reflected on the price of the platform and the very fast turnaround of technology. So hopefully this answered the question.
How many are not working anymore since the launch?
How many
So
of the
actually
satellites not working?
Yeah, so just to give you an idea of how the constellation is doing, the second satellite that we launched, the one that we call X2, is still on commissioning and operations. So it has been more than 4 years and a half that is still operational. So they are definitely can last more than 3 years, but 3 years is the time that we feel comfortable sharing and guaranteeing maximum performance. Of course, there are incidents that can occur in orbit due to radiation events that can affect the performance, but so far, the majority of our satellites are completely operational.
There you are. I hope that answered the questions. Then we give to Dr. Ade Kumar over there. Sana Pak. Minta tolong. So bear with us. One more questions from the floor. Yes.
Okay, thank you, Dr. Gio. The first question is regarding the constellation. How many satellites you have in operation right now, and it will be related to the repeat time or visiting time across a certain area. How many days we can get the data from your constellation? The second one is on the your spotlight mode. It looks very impressive. So what is the maximum size of your spotlight data, both the normal spotlight and the fine spotlight? So what's the maximum area that you can provide the data for the spotlight? Yeah. And then in terms of cost, how much
it's all about the price.
Does it cost more than the strip map mode? So you don't need to mention the exact euro, but if we like to order spotlight mode data, how much higher it will be compared to the spotlight, the strip map data based on, let's say, square kilometer. Thank you.
Yeah, you can directly answer.
Yeah, so regarding the revisit time, we have several satellites that are in the 1-day repeat orbit. That means that we can revisit the same target in a daily matter in some cases. And if you're interested in coherent repeat, we have multiple satellites, so you can actually cover the area quite often. So it's not a matter of several days, but rather several hours that you can get the image, depending on the particular positioning for satellites at the moment of the request. So that's one thing to mention there. We have over 20 satellites. I actually don't remember the exact number, but we're going to launch like 5 more soon. So it's hard to keep track. And about the pricing, I will maybe like to answer that question through email, not to say the wrong number. but the costs are not that different and they are not that high. It's actually quite an affordable platform. So the images are on the lower side, especially if you compare with the all space market. So I think we are one of the leaders, and that includes pricing. So maybe what I would recommend is that please send an email to my to myself. Send an email, and I would like to answer that. Put you in contact with the right people to give you a perspective of what is the pricing scheme and so on. You also ask about the particular size of the spots and the dwell.
Spot mode.
So in spot mode, you can have a 5 by 5 kilometers area with 50 centimeters resolution, which is the highest resolution that we show, like we provide at the moment.
I hope that answers your question, Dr. Ade. Yes, thank you very much. We give applause to Dr. Oscar GL. Thank you for your time with us. And anyone who would like to continue communication, he has his email and the company profiles as well. Thank you, Dr. Oscar GL from Finland. I will continue to the third speaker, sir. Thank you very much.
Thanks a lot. Please enjoy the conference, and has been a pleasure to present for you.
Yes, we actually wish that you come over, but unfortunately something comes up, then you cannot make it.
Yes, I think in the next iterations of this conference, I would love to be in person.
All right. Thank you very much once again, ladies and gentlemen, Mr. Oscar Giel. Now we move to our final speaker for today. I hope you are still awake until the end of this session. Because our next speaker is a very prominent SAR researcher. Why? Because we already have from NASA, from DLR, yeah, and researcher from other countries. Now we have our Professor Josephat Tatuko Sri Sumantio to come and take stage. Okay, actually, Professor Josephat is not representing Indonesia, I believe, Sensei. He is representing Japan because we should have 3 countries within one session. So we have one Indonesian, one from Finland, and one from Japan. Just quickly, maybe I don't have to read all this biography for you, then you can just talk with that. Well, anyway, let me just make it brief. Again, as I mentioned, Professor Josephat, actually based in Tokyo in University of Chiba University. Most of his studies in Japan, in Kanazawa University. And now, if I can just make it short, he's a professor at, this is the last assignment, Health and Disease Omics Center in the Faculty of Medicine. Wow. and the other one. And the honorary professor, yes, I need to mention that. Yeah, he is also an honorary professor in Institute of Technology Bandung and also in UNES, University of Semarang. You are an adjunct professor in there, yeah? So, of course, you still need to dedicate your life also for Indonesia, not only Japan. Okay, ladies and gentlemen, please welcome Professor Josephat Tatuko Sri Sumantio. He'll be talking about CPSAR. So if you talk about the technology and advancements of technology in SAR, he'll be talking about CPSAR, especially on how these microwave sensors for disaster and environmental monitoring. You got the mic on? Yeah, it works. Yes.
Okay. Yeah.
Time is yours, sir.
I think it's
yes.
Okay. Yeah. Thank you very much,
Oris.
Dr. Ilham. Yeah. And it is my great pleasure, yes, to introduce the progress of our some project, yes, in our laboratory. Yeah. Actually, my laboratory is you can find here JMRSL. It is Josephat Microwave Remote Sensing Laboratory. Yeah. In Chiba University is Josephat Laboratory. Yeah. I think actually this symposium is managed by mainly by alumni of Josephat Laboratory. Yeah. Because yeah. Thank you, friend. Yeah. Yeah. We already graduated, I think it's more than 20 students that came back to Indonesia and focusing for the synthetic aperture radar that already presented by Dr. Heru. Yes, I hope they will develop and then launch the satellite in the near future. Yes, and today I want to roughly, yes, about what we already have done in my laboratory. Yeah, my name is Josaphat Tetuko Sri Sumantio. Please call me Josaphat or just Josh, Josh. Yeah. Okay, and it is some of our facility that we already developed. My design unmanned aerial vehicle with the wingspan is 6 meter. Yes, for the 4 kilometer altitude and 4 hour mission. Yeah, and right now is we develop a 28 meter wingspan that for one flight is 6 months. Yes, continuously. Yeah, I hope we can operate this system in Japan and also some of country, including Indonesia. Yeah. Okay, and the other one is for the CN235 MPA and also Boeing 737 we already installed here, and also the our microsatellite. I think you can remember one of the company that already launched with our design. Yeah, and it is recently my books that published in CRC Press. You can find from the how to design the theory, wave scattering, yeah, and including how to design the hardware and including the antenna, yes, and SSPA, and I think it's very detailed, yeah, and about the ground test and flight test and image processing itself. I think it's here is like Izumi-san is came here, and also Chahya-san is also my former student and now is working in BRIN and also the Murorang Institute of Technology. Okay, today I want to show you about the development of microwave sensor for the disaster environmental monitoring. Yes. Okay, next. Yeah. Could you move? The next slide. Okay, this is the content. Is first in the background and objectives concept of the CPSAR. Okay, I just want to focusing to the CPSAR, circularly polarized synthetic aperture radar. Actually, we developed some sensor, including some sensor from the moon. Yes, one of my students is working for the moon observation and also for the Mars observation. Yeah, and the other one is okay, the concept of the CPSAR, circularly polarized synthetic aperture radar. Yeah, and the system itself, mission and roadmap, flight mission, image processing, and finally the shot of the microsatellite on board CPSAR. Yeah. Okay, next slide. Yeah. Yeah. Okay. Yeah. Thank you very much. Okay. Good. Yeah. Yeah. This always controlled by ourselves better. Please don't lose control. Yeah. Okay, yes, the background we developed actually because we are working in Chiba University under the Ministry of Education and Technology of Japan. So in this cases, we focus on the disaster, yes, observation and also environmental observation. So in this cases, we want to observe the landslide, earthquake, subsidence. Actually, well, our focus project, yeah, because Japan and Indonesia, you know that we are in the archipelago. It means many islands. Like Indonesia, we have 17,000 islands. Yeah, so you can move every day from Bali. You can start from here, and you can move one island, another island. I think until you die is not finished. Yeah, yeah, yeah. So we have many, you know, a lot of the island. Yes, so in this case, you can buy one island in Indonesia if you have money. Yeah. And you can develop, yes. Actually, yes, it is just my dream. Yeah, to buy one, at least it's one island. Yeah. Okay, yes, and next, I think you already know about the synthetic aperture radar, and we want to promoting, it's not just the research, but also the education. I think the education is very important. So why I promoted like the short stay program, long stay program for Southeast Asian student, yeah, and also from the Korea, and one of the staff of the contact, you know, Henzang, Kinsang is our what is exchange student before with the Aju University at Korea. Yes, and then some of here is I think is all is already visited my laboratory. Yeah, and for the long stay and also the short stay, sometimes the postdoctoral program, and we also promoted with the degree. Yes, means the double degree program. Yeah, and like Rikasang is also the double program in my laboratory, and I think some of the attendant is now is double degree program in my laboratory, like Arif Sang and next is Yoshimoto Sang and so on. Yeah. Okay. Yes. I hope you know how to make the networking. Yes. It's not just you come to the conference. Yeah. In my consideration. Yes. You can go to the the leading laboratory, and then you can make strengthen to strengthen your network. Yeah. This is what I'm thinking until right now, including this one. This symposium. I hope, especially young scientists here, please find many friends during your at least is when you attend the symposium 5 days, please find new 5 friends. Yeah, and then also look after and keep 5 old friends. Yeah, this is I think is very important. Yeah, and this the objective of my laboratory is collaborate with the domestic and international institutions to develop the multi-band. Multi-band is some of the frequency. Yes, synthetic aperture radar or SAR on board for the UAV aircraft, and we also develop the high altitude platform system hubs. Yeah, and also the micro satellite. Yeah, especially for the airborne and micro satellite SAR mission. This is some of already we flew. Yes, this is Boeing 737 for the X-band. C-band is for the CN235. Maybe you can find the CN aircraft is made by the Indonesian company, and the first name of this aircraft is my name. Yes, Tetuko. Yeah, I think many people here know. Yes, because my father is the Indonesian Air Force. Yeah. Yes, it is. Tetuko is very famous in Indonesia. Yeah. Okay, and C-band, it is also for Cessna, and the L-band one is our first L-band system that we install in our also in my UAV. Okay, I think you cannot find some this typical or original shape of the UAV. If you want to borrow, please call me. Yeah, you can rent from me. Sorry, just joke. Yeah, you can, I can, it's not gift, but we can join to use this, our UAV. And also the microsatellite. Yes, it is, we work for the multi-band. Right now is L-band and C-band. Yeah, one of my student before is Katia Sang, I think here. Yeah. Katia Sang is now working at European Space Agency. Yes, he worked for our this project before. Yeah. Okay. Yes, the concept of the circular polarized synthetic aperture radar you can see here. For the transmitter and receiver is fully the circular polarized antenna. Okay. So I think commonly the synthetic aperture radar is the linear polarization, horizontal and vertical. But in our cases, we develop on the circular polarization. Maybe some of you want to know about what is the benefit, and you can find in my books. Yes, it's some of the reference that refer to my laboratory publication that already published in IEEE. Yes, and like the Springer journal and so on. Yeah. And also we have the patent itself. Yes, it unfortunately in Japanese. Yeah, yes, related the circularly polarized synthetic aperture radar for the drone, airborne, and also for the microsatellite. Yeah. Okay. Yeah. Next is sorry. It is what we already developed in my laboratory. It is the real picture of L-band for the drone itself. Yes. It is L-band for the microsatellite, and C-band and X-band, yes, for the CN and Boeing 737. And we also developed this drone with one company in Japan that we can fly for the 2 hour. Yes, a 2 hour flying. Yeah, this is hybrid using the gasoline and also the electric. Yeah, I think it's if you use the common quadrotor, I think it's just 30 minutes or 20 minutes based on the payload. Yeah, but in our case, it's 2 hour because Japan is many disaster. Yeah, and we cannot reach the impact area. Yeah, so why I'm working in the disaster research center in the department, in the faculty of medicine in Chiba University, because I developed this one is for the doctor and some nurse, yeah, that they want, or they want to access to the disaster impacted area. And then this one we developed, yes, this is with one of the company. I'm sorry because I cannot mention the name of the company here. And then we fly for once mission is 6 months. Yes, 6 months. And yes, we can use this payload is 30 kilogram using C-band and the X-band for this moment. Yeah. Okay, for the detail is you can read my book. Yes, I think the price is 200 pounds. Yeah, it is the promotion. Okay, I think it's very cheap. You can find it's very detailed information. Yeah, and it is the roadmap in my laboratory. We already developed around here. Yes, it's many, including our own ground station. Yeah, and then right now it's running. Yes, for the hubs. Yeah, high altitude platform system. And actually, we want to fly in 2019 at the Papua Biak airport and the Morotai. Yeah, we already arranged, but unfortunately, the COVID. Yes, I hope in the near future we can fly in Indonesia. Yeah. Okay. Yeah. Okay. Next. Yeah. Okay. From the mission is you can find this is because we must consider the Japan and the situation in Japan and also in Indonesia in my case. So in this case, right now is in Indonesia we already built many infrastructure. I think it's 5 years or 10 years later we have many problems. Yeah, how to manage this infrastructure? We already released a couple months about the high speed train. Yes, Jakarta to Bandung is my hometown. Yeah, and also the highway. Yes, from the Cilegon. Yes, until Banyuwangi. Yeah, it's very long. It's more than 800 kilometers. Yeah, but noise we need to observe. Yes, I think it's some of you you can promote your product in Indonesia. Yeah, and then we can use your product. Yeah. Okay. Yes. This symposium I think is you can also make the interaction between the the hardware and also the what is the user. Yeah. For the synthetic aperture radar. Okay, and for the home security and anti-terrorism, yes, I think it's Japan itself with the northern country, yes, have the some problem. In Indonesia also, of course, we have with the northern, eastern, and also western, yeah, and also sometimes it's from the southern area. So in this case, we need to how to manage our country because Indonesia is very long. Yes, you spend 7 hours from the Sabang to Merauke. Yeah, it means Indonesia is from the Spain until Kazakhstan. Yeah, it is very long. So you need, I think, strong sensor. Yes, that I think one is, of course, I must promote my sensor is synthetic aperture radar. Yes, including the optic sensor. Okay, the other one is okay. Yes, I want to skip this one. Yeah. And for the books of my research is you can find this one is I think it is a new one. Yes, related the airborne, sorry, the spaceborne SAR. Yes, it is one chapter is I wrote. Yeah, and then this is fully for the airborne circular polar synthetic aperture radar, and this one is for the drone CPSAR. Yeah, all is I think is detail. Yeah, in detail. So please read. Yeah. Okay, this is our product, and with the resolution from the C-band, for example, it is a 37.5 centimeter. Yeah, I think it's very good resolution. Yeah, we want to improve more, so why I discussed with some of the company how to improve this our hardware. Yeah, and compared to another mission, yes, I think it's another mission is linear polarization, and we are fully circular polarization. Circular polarization is not so easy, yeah, because how to consider the broadband the gain, yeah, gain of the antenna, of course the system itself, yeah, and also the acceleration ratio, yeah, how to keep less than 30 dB, yeah. If possible, it's 0 dB, but it is impossible. Yes, with it's very large bandwidth. Yeah, but my student is very excellent, and they develop some of the broadband antenna. Yes, right now is I think some student is about 2 gigahertz or some 3 gigahertz bandwidth. I think it's very nice. Yeah, because from the 400 gigahertz we got about 37.5 centimeter. Yeah, if for example 2 giga, it means 7 times, 6 times. Yeah, it means more better. Yes, about 5 centimeter. Yeah. Okay, yes, I will show you some of our mission. This one is using the Tesla. It's me and some of my students from Germany, and some is from the former Lapan, is now is to be in the BRIN, yeah, and also from Indonesian University, also Bandung Institute of Technology, and also Gajah Mada University from Professor Aris. Right now, he is the head of the big, yeah, and now is some people is to be, is nice, right? It's like Professor Aris. Yes. This is thank you very much for this collaboration. Yeah, we have many collaboration with some of the institution, including in Korea is Ajo University, and also sometimes before is I also have give some advice from the Korean Aerospace Agency, also the KAIS, yes, at Korea, and also Taiwan. Yes, Taiwan Aerospace Agency before in the NSPO, and now is to be TASA. Yes, I developed the C-band for them. Yeah. Okay, and this is this morning. The next way develop the radome, and I have to develop the new radome using the polymateria, and got this very nice radome. And yes, now this material based on our research is used by the, it's very famous company in Japan, SoftBank, yeah, to use for the tower, yes, a tower on the 5G and 6G telecommunication, because this repeater is very huge, yes, and also very weight, so we need the light tower, so they use our material. Okay, we want to replace almost all of the tower in Japan at least, yes, and in the future as we want also replace the tower in Indonesia. Okay, it is in the circularly polarized SAR antenna, and it is in the system that we install in CN235 aircraft, transmitter, receiver, and controller, and also the battery itself. It is for the module to control our system. We made some experiment without the radome and also including the radome itself. It is our first circularly polarized synthetic aperture radar images, yeah, with the resolution 37.5 centimeter. Yes, and then yes, we got many images, and you can read, just put in IEEE is the airborne circularly polarized synthetic aperture. I think you can get this paper. It is free of charge, so you can download. Yeah. Okay, yes, and this my microsatellite. It is with my student Mirza, is you can find in the contact right now. Yes, and the Japanese guy, and also these two guys, Chaya Sang and Pebelin Sang, is now working in BRIN. Yes, and Katya Sang now is working at the European Space Agency. and Chuasang is working at Malaysia. We are very international laboratory. Yeah. So why? I think I like children and also pet. So I have the dog is called the Coco. Yeah. This is I love very much. Yeah. So I love, of course, my student, because my student is my children. So I keep them as my children. Yeah. Because they came from many countries, then I must look after them. Yeah. So I think they feel like this one in my laboratory. I hope. Yeah. So we have many party. Almost every month is one or twice of the party. Yeah. Okay. Yes. It in the system itself. Yes. Okay. I hope the time is okay. Yeah. Okay. Yeah. Thank you very much. I hope you can imagine what we are doing in our laboratory, Josaphat Microwave Remote Sensing Laboratory. I'm very welcome to all of you. If you visit Tokyo, yes, our laboratory, Chiba University, is just 35 minutes from Narita Airport. Yes, if by car, I like the sport car. So I'm always ride the Toyota 86. Yeah. So this is just less than 30 minutes. But it's very dangerous. Yeah. So please visit my laboratory. Yeah. Okay. Thank you very much. If you want to call me, so just insert JMRSL. Yes, I think it's in the word. It's just this is just my laboratory. Yeah. Okay. Thank you very much.
Thank you, Prof. Thank you very much.
Thank you very much.
Give a
okay. Yeah.
again a round hands for Professor Josephat. Please stay, sir, because we have a question and answer at least for each of our speakers. So, ladies and gentlemen, we still have time for you, your curiosity of Josephat research, because I was one of his students last time as well. Although I was sent to the third floor laboratory studying atmospheric science rather than having JRMSL with Professor Josephat. Okay, please, if you have any question, comment, or anything related to CP-SAR or possible technology of SAR, raise your hands. Anybody? Or you already had enough of this talk this afternoon? Dr. Upendra, you have any comment on JOS? No? It's a wonderful. Yes, very nationals and many other, and some of the students are here actually to support. Okay.
Oh, maybe yes. In my laboratory is mainly is doctor student. Yeah. We have the maximum is 20 student of the PhD, and totally with the master and bachelor is around 37.
Yeah,
it looks like small company.
Yeah, it's just a small company.
Yes, and then we have many topics. Yes, but one is one topic. The focus topic is the CPSA. Yeah, and how to solve the SSPA and so on. Yeah, and the PhD right now is we have about 10. Yes, after this COVID is now gradually increased. Yeah.
And Professor Josephat also built a connection with Indonesian University if they would like to continue in his laboratory, so they can be funded by scholarship and they can.
Yeah.
There's a privilege. We have some double degree programs within Indonesian University.
Please welcome.
Thank you very much.
Yeah.
Maybe one more comment.
Sorry. Maybe yeah. Actually, I also have some activity. My family have the scholarship foundation. Yeah. To give the scholarship for Indonesian, children. Yeah.
Right.
And one of the, I think at least I know one student is now is to be the brain researcher.
Wow.
Yeah, I supported from she was the elementary school student. Yeah.
Until graduating university.
Yes, and I also the two foundation in Tokyo. Yes, it is in the Achemi Scholarship Foundation and Satoyo. It is I'm the counselor. how to manage, how to give the scholarship and come to Japan.
So not only doing research, but more on the human educations as well.
Yeah.
One more comment probably from my left side. Nobody? All right. I think they already have all enough with the presentation today. So ladies and gentlemen, once again, Professor Josephat Tetuko.
Thank you very much. Yes, please enjoy Apsar 2023. Yeah.
Yes, thank you. Thank you once again, all speakers. Now I would like to give back to the MC, our Master of Ceremony. Conclude my job as a moderator. We'll be meeting again tomorrow for some of the chair and parallel sessions. I hope you can take advantage of this session because from the three speakers, we have Prof. Aris as the part from the government. Then we have one from ISI from the commercial side, and of course, Prof. Josephat Laboratory as part of the research sides. So as you can see, this conference is trying to combine the whole stakeholders of SAR application and technology. That would conclude my moderating sessions. Thank you very much. I return back to Ibu Rika. Thank you.
Thank you, Dr. Ilham Alimuddin. But first, I would like to invite again all the keynote speakers. Professor Josephat, please come to stage again, and then Professor Muhammad Aris Marfai, please come to stage again. And then maybe if Oscar still online. Okay. And then Dr. Ilham Alimuddin, please come back to stage again, because we have a ceremonial gift that will deliver by Dr. Upendra Singh. Please. To hand over the token of appreciation for the keynote speech and the moderator. And then for Oscar, it would be okay. Thank you for Dr. Upendra Singh, Professor Josephat Tetuko Sri Sumantio, and then Professor Muhammad Arif Marfai, Dr. Oscar, and Dr. Ilham Alimuddin. Well, ladies and gentlemen, the next agenda, please welcome Professor Junichi Susaki to present the flyer of Apsar 2025.
Distinguished guests, participants, and ladies and gentlemen. I'm Susaki from Kyoto University. I'm going to present and report to you the next venue of IPSA 2025. Before that, I express sincere thanks to Professor Josaphat and his team for having a good, successful IPSA 2023. And not only this one, but also 2 years ago, you had a hard time to have a online 2021 IPSA. I sincerely express my thanks to you. And 2 years ago, we had a council meeting that where we should have a next IPSA. As a result, Japan was selected. Then we started the discussions where we should have a conference. Okay, yes. Time and place is like this. In 2025, in October, we are going to have a IPSA. We had a long discussion where we should have Tokyo, Kyoto, or other cities. And as a result, Matsue is selected, the western part of Japan. Please raise your hand if you have been to Japan. How many people have been to Japan? Oh, more than half. Okay, thank you. How about Kyoto? Kyoto. Oh, I see. How about Matsue? Yes, only one people. It's okay, it's okay. This is our expectation that Matsue is a very good city. We promise that you never regret to go to Matsue because they have a lot of good aspects about Japanese culture and the history. Okay, I introduce several aspects: main hall, banquet, excursion, and sports. Yes, Matsue is located in the western part of Japan. And if you fly to Tokyo, we have many flights from Tokyo to Matsue. Also, there is a flight from Osaka. If you have a chance to visit Osaka or Kyoto after you finish IPSA, it's very easy. Only one flight from Shimane to Matsue to Osaka. You can enjoy Kyoto or Osaka and you go back to your country. Then Matsue has 2 airports like that. This like this, Matsue has 2 lakes like this. So you can enjoy the scenery, also the seafood like that. It's the transportation. We have several transportation by train or airport, airplane like this. This is just a tentative schedules. Like this year's IPSA, we are planning to have a 4-day conferences and like this, but it is very tentative. We may change our schedule. So just 2 weeks ago, we went there and to see how the condition is, how access is okay or not. Then this is the main conference. Unlike this conference, our hotel accommodation is not included in this one, but it is very short area, like less than 10 minutes walk from this venue. The main hall is there, and we check that the accommodation room is enough to have 3 parallel sessions. And banquet, maybe you are expecting this one. And banquet place, we promise that this is very beautiful and very good place. And a very traditional Japanese garden is there. Then, wow, you can enjoy. The stream is released like that. Every 15 minutes, they release and to enjoy the scenery. Then, all through the year, this botanical garden is operated. So you can enjoy the Japanese flowers. And you can enjoy the dinner and from the such kind of room like this. Also, the Japanese entertainment dancings will be provided. Around this venue, there is a castle, old castle, and you can take a boat to go around like this. And this is one of the famous shrine in Japan. Maybe you don't know, but this is very famous, Izumo Taisha Shrine. It is not Okay, we take maybe a bus, less than 1 hour, but you can go easily there. And also, this is another aspect, Adachi Museum Art. I didn't know this history, but it is very famous for this Japanese garden, and it has been #1 ranking in Japan for 20 years, like this. Then there is a beautiful art, so you can enjoy it. And also you can take a cruise, and you can enjoy this. So my presentation includes a lot of activities, but I hope you enjoy in this Matsue. And after that, please enjoy the stay in Japan. Okay, again. So see you in Matsue in 2 years later. That's all from me. Thank you. Particular. Yes, we have a candidate, but okay, in the middle of October. Middle of October, yes. Yes, we have a short video to introduce Matsue.
100 views of Matsue, the water city. The curtain rises with a dramatic flourish. The morning sun glinting on the water, small boats trawling for clams. This is the capital of the province of the gods. It is the water city of Matsue, where the beautiful lake and waterways reflect the changing seasons. Here are ways to get to the water city Matsue. Flights for Matsue use Izumo Airport or Yonago Airport. There is a direct airport bus service to JR Matsue Station from both these airports. By rail, change to the limited express Yakumo at Okayama Station. It takes 2.5 hours to reach Matsue Station. By car, it takes roughly 1.5 hours from the Chugoku Expressway, Ochiai Junction, to Matsue via the Yonago Motor Road and the Sayun Expressway. The history of this town stretches way back to the age of the gods. The southeast of Matsue City flourished as the heart of ancient Izumo and is dotted with many venerable shrines. The legacy of the province of the gods has been passed down here to the present day, along with its festivals and rituals. Matsue Castle is a symbol of this castle town. One of the 12 castle towers still in existence in Japan, it proudly presents a simple and sturdy appearance, with black outer walls and no superfluous ornamentation. Traditional and unchanging Japan still lingers in the castle town of Matsue. You can gaze upon the seasonal sights of the castle town from exotic Horikawa sightseeing boats that ply the moat around the castle. The area north of the moat is known as Shiomi no Ate. Scenic and historic spots, such as the Buke Yashiki Samurai House, are evocative traces of a bygone Japan. Matsue is a city of gastronomy. The Japan Sea and Lake Shinji are blessed with an abundance of marine products, providing exquisite delicacies. The most famous winter delicacy of the Japan Sea is the snow crab. These can be boiled or grilled and are superb in the pot or as sashimi. They truly are the king of the winter delicacies. As well as which, there are the 7 delicacies of Lake Shinji, one of which is the nationally renowned Yamato Shijimi clam. And then there is fresh seafood, Shimane Wagyu beef, Izumo soba. This truly is a city redolent of refined gastronomic delights. Matsue is an onsen mecca, and a hot spring inn is the place to go if you want to get the full flavor of Matsue. The famed Tamatsukuri Onsen boasts a nationwide popularity. Guests are treated to painstakingly prepared dishes and hot springs that are dubbed the waters of the gods.
And this video is
very much. Successful symposium. Cheers. Bye-bye.
The finale of our trip to Matsue, the water city. It is the Lake Shinji sunset, when the lake casts its most vivid light. The drama of sunset reaches its climax when Yomengashima Island becomes a mere silhouette, and at the same time, it presents a calm and poignant finale. Matsue, a water city crisscrossed over and again with dazzlingly vivid light and colors.
Okay, please have a big applause for Matsue.
We are looking forward to you coming to Japan. Okay, thank you so much.
Thank you. Thank you, Professor. Can wait for looking have to Matsue, yeah, in the next 2 years. Okay. Okay, thank you. So, ladies and gentlemen, now please have a look for Balinese dance of Merak Angelo. The Merak Angelo dance is the movement of a male peacock, proudly showing off the beauty of its long and colorful tail feathers, while contorting its body with the aim of attracting the attention of female peacock. Merak Angelo dance was created by Mr. Iketut Rena and Mr. Idewa Dharmayasa, who is a percussion artist from Bali. This dance is danced by women because women are considered more suitable and graceful to reflect the movement of peacock. So, ladies and gentlemen of the happy audience, let's watch the Merak Angelo dance from Udayana University student. You girls, please wait. Girls, the dancer, please come back again. To the dancer, please come back again. Please come back again, please. Come inside. Don't be shy. And please take a position. If there is two participants who want to having a photograph or a picture with the dancer, with the Balinese dancer, please come with us and join with us. Sure. Just Dr. Opendra? Okay. So everyone, if you want to have take a picture with our Balinese dance. Okay, we are having take a picture together. And everybody please stand. Okay. And then don't forget to upload to your medsos or Instagram or Facebook. And then take a hashtag of Apsar 2023. Okay, get ready. Huh? Okay, get ready. 1, 2, 3, say cheese. Again, say Bali. Oh, wait. Once more. Say Bali. Say Apsar. Okay, thank you so much. Okay, to distinguished ladies and gentlemen, thank you very much for your participation at the opening ceremony of Apsar 2023 and iCares 2023. And then for the event for tomorrow, we are going have 3 rooms. That's the one room and the first room, and then the second room, it will be in main hall in this room. And then the third room, it will be in Nusa Lembongan at ground floor. Yeah, the participant or presenter who will be present their presentations, there are 3 rooms. The first room and then the second room, it will be in this room. And then the third room, it will be in the first floor or ground floor at Nusa Lembongan 2. Okay. And then tomorrow for lunch, tomorrow for lunch at a Golden Lotus restaurant at the lobby for tomorrow lunch. And then for tomorrow gala dinner, okay, we are invited you all to having a gala dinner with us at H2O restaurant that's in outdoor resto close to the swimming pool in this hotel. So we are expecting you to come with us for gala dinner tomorrow at 6 p.m., 6:30. At 6:30 for gala dinner, okay? And then for the executive meeting, it will be tonight, this afternoon at 6 p.m. until 8 p.m. At first floor at Premier Lounge, okay? First floor at Premier Lounge in this hotel. Just VIP, just VIP guests, okay? Thank you so much, and don't forget to download our technical book on website of Apsar, and then you can find your presentation or your schedule of presentations. Okay, thank you so much. See you tomorrow.